Yo, long time, no stream. What up, everybody? Welcome to development stream. We're gonna be doing some auto routing stuff, optimizations. We're gonna be using JavaScript's tools to debug the magical world of auto routing. I didn't want to do too many auto routing streams. I was like, man, sometimes when you're building an auto router, you're just kind of staring at the wall, trying to figure out, what is going on. But it's mostly working now. There's some big boards I can't route, or at least they're a little bit slow. So gonna do some optimization stuff today, low-hanging fruit optimization. And then we'll do other stuff. Yo, what up, Ayush? Welcome. Good to see you. Some awesome contributions lately. Maybe not lately, but definitely around. Let's take a peek. If we got anything on the board, just to call you out right away. Actually, board's pretty weak so far for everybody. I guess it's because it's Saturday, so we only really had one day to do stuff. But yeah, that's fine. Not a lot of time. So anyway, this is slowly auto routing the node solver phase. This is where we determine kind of like at a high level where traces can travel, but there are some pretty small nodes in there. So basically what I'm going to do, I'm going to run this guy. I'm going to look at the pipeline. We're going to see where there's opportunity to make it faster. So very, very simple concept for a stream. And I kind of want to build a keyboard, but I don't know if I'll do it on the stream. We'll see. Just to have it to benchmark. So we'll see. Maybe that'll happen. All right, so I'm going to hit solve completely. It's going to, instead of animating through the solution of the board, it's going to solve the entire board. So solve the entire board. There's our nice looking routes. Somebody mentioned on Discord. Let's see if we can get Discord up. Hopefully nothing private comes up. Somebody mentioned that there's going to be route purists, and they're not going to be very happy to... that might not be acceptable because there will be route purists that require perfection. All right, I'm going to give it a high five. I don't know about purists. They probably exist. Oh, man, there's a lot going on here. I haven't read it in a little while. Yo, what up, Anch? Good to see you. How are you? Anyway, we can see how long each stage takes, and one of the stages that I'm most surprised by is this single-layer node merger. That is not a very intense phase. Let's take a look at that phase in animation. Single layer node merger. So it's the third stage. So I'm going to hit next stage. And I think it will animate if I hit animate now. With robe and everything. Good morning. Yeah, it's early for me. And I can't give enough shits. The only way I'll actually pull into, by the way, good to see you, Imposter. The only way I'll convince myself to start streaming after I haven't streamed for a while is if I'm like, all right, there's no need to give shits, just hit the button. So this phase takes forever. I think it's just merging nodes, and I'm guessing it's doing a bunch of n squared checks in there. What happened? Why stop stream? A bunch of stuff. I started a startup accelerator. Thought was going to be a ton of effort. It's a little bit more lightweight than I thought, so technically I'm still in it. It's a little bit more lightweight. Maybe it's not lightweight and I'm just not doing enough of the work, so that's another perspective. But yeah, that happened. I had to file taxes and do all my accounting for the company. That took a while. I was also just doing algorithm development, which is not even something I probably can stream. The only reason I can stream today is because we're doing optimizations. Algorithm development is pretty tough. Hey, I thought you'd forgotten me. Forgotten you, Ansh, didn't I? Don't we like talk on Discord sometimes? Was it like 3 days? It's like high school girlfriend energy. That's what I call that. Yeah, I guess I can kind of see why this takes forever, especially if it's doing an n-squared check per node. You can actually see the iterations there are supposed to go pretty fast, and they're actually going a little, well, it's kind of hard to tell. So there's this iteration count up here, and it flies up as the algorithm goes, but it's capped. You don't want the algorithm to go too fast, or else you won't get a good animation. It is tough. You need your thoughts and yourself for that. No distractions. Yeah, I mean, it's just not good content. That's how I think about it. I'm like staring at the screen, and if anybody distracts me, I'm like mad at them. You know, it's like, it's just not a good, but the algorithm is mainly developed. There's like a couple things I want to do, like what we're doing today, but like, there's not like a ton of novel things that we need to build for it. It's like, this thing is friggin' fast. My goal is to have the fastest autorouter in the world. I'm pretty sure we're gonna have that. Maybe other people will claim, but I keep looking at videos of autorouters, and I'm like, that is neither fast nor like decent. Like, it doesn't complete that much. Maybe some people have decent stuff. Is it client-side compute? This is all running on the browser. People are like, oh my gosh, you guys are going to have your friggin' minds blown this stream. If you stick around, people are like, oh, why are you writing performance stuff in JavaScript? One, JavaScript is ungodly fast for nobody knows, you know? It doesn't make any sense, but it's just really fast at doing some things. That's one. Two, it has the best profiling tools like ever. It's crazy. It's so good. So I'm going to show a little bit of that off, and you guys are going to have your minds friggin' blown. I know my mind was blown when I saw how good JavaScript's profiling is. So, with that, let's take a look at optimizing the single layer node merger. I think I already might have this. Do I have this isolated node merging? I don't really have it isolated. So I think there's probably like 2 ways I can do this. Why don't I show you guys the optimization flow a little bit, how we're going to measure. So we're going to pull up the performance panel, performance tab. Can I make this bigger? I'll make this slightly bigger. I don't want to make it too big, though, because there's a lot. There's a lot we need to see. So performance panel up, I'm going to hit record. I'm going to hit solve completely, which runs the entire algorithm. Okay, and then we're going to hit stop on the profiler because it's solved. And now we get to see what took up the most time. And sure enough, you zoom in here, like auto routing pipeline solver. Yeah, single layer node merger. It's kind of hard to see, but it says single layer node merger on there. If we keep zooming in, we can see get adjacent unprocessed nodes is this like very, very expensive function. That's why it's explicitly marked here. Basically, the program is spending like 99% of its time in this function. But wait, there's more. You can click on this, and we can go to our source code, and we can see how much time is spent on every line. Look at that. That's insane. So I'm inside the get adjacent same layer unprocessed nodes function, and I can see that 1.7 seconds was spent on this one line. Are you guys minds blown? You can see how much time is spent on every line of the program. That's nuts. I didn't do anything. I haven't even started yet. So anyway, so is it client side? It is, you know, it is all client side, and optimizing it is really, really great. Can it be parallel and server side? It can be parallel client side using web workers. Here's the thing. My end goal is to have a website where somebody, by the way, Mr. Comp, hello, welcome. But my goal is to kind of have it so that it's really easy to run. It's not like super system requirement heavy. So like you can upload your KiCad file to a website and it'll auto route, and whatever. But yeah, but we do web workers all the time. So if we like, okay, this is the problem. Let me just you're the problem. No, but this is the problem is people are like, why don't you write it in C? Why don't you do this and make it parallel and blah, blah, blah. You can't hit it too quick. You can't just jump in and go for those. Those are how you milk out like the last 20%. That's not what you do at the beginning. You got to fix your fucking algorithms. You know what I mean? Sorry, I just got E-rated. My E rating is gone. But like, if there's an n squared loop in here, you got to look at that before you like, you know, before you do anything else. So one thing I wish this had, and I'm super new to this tool, by the way, like the little demo I gave you is really just the basics. Like I like there's so much I haven't even explored yet. But like memory inspector and stuff like that. But the thing I don't know is how many times is this called. So you can spend forever. And fun fact, this took 20 seconds. Actually, I think it took more than 20 seconds. I think it took 30 seconds. And using this timing here, I just changed the order of these lines to make the least likely ones execute first, the fast and least likely ones. And I increased it to 5 seconds. So how the F would you do that in any other way except this tool? You know what I mean? Friggin' crazy. Friggin' crazy. Language. Got kids around here. Yeah, sorry about that. Yeah. I know I've been derated. Look, man, this guy just got me, you know, he got me all twisted up, you know, client side. What a friggin' jerk. Boo. Sevi, the site is still not working. I think Rashab has fixed it. What site? tscircuit.com? tscircuit.com is down? Or are you talking about like maintenance tracker stuff? I don't want to get too distracted. Is something actually broken, like serious? I might help people out with their issues. I do like to like help people out with their issues, but I also, you know, I wanna like get something meaningful done on with the thing. Yep, tscircuit.com is down. People should just be merging if tscircuit.com is down. Wait a second. Okay, that took way too long to load. What are you talking about, Ansh? Everything seems to be working. Everything is working, man. What are you talking about? Check Discord. All right. Why can't we have full thoughts? Like, why am I, you know what, dude? Describe the problem. You know what I mean? Like, why do I have to read so much? I guess I'm asking you to describe what you have described here, but still. Status is fine. That's localhost, bruv. That's localhost. That's a system issue. You can resolve that. I'm not going to resolve system issues on stream. I'm not IT support. All right, single layer node merger. So yeah, get adjacent unprocessed. See, I'm like reloading into context. This is why it's so hard to do algorithms with stream. You know, I'm just punishing Ansh right now for how many few brain cells I have. Get adjacent, same layer process. Okay, so my theory is this can't get much faster. I asked Claude to do a benchmark of set performance, which was very eye-opening because sets execute really, really quickly. They, it's like 1 nanosecond each time. I thought sets might get slower as you add more items, but it's basically like, you know, literally like a nanosecond or I guess 8 nanoseconds every time you access a set. So, sorry, Ansh. You know, I got stupid brain. I can only handle emergencies and algorithms. That's my Yeah. So basically, I thought maybe we could optimize this line or one of like I guess this is a map, but yeah, it's probably not going to work. Oh, this one's a set. I guess this one's a map. I don't know. Map access is probably similarly fast. I imagine they use the same thing. So my point is, we're just executing this a lot. I think it's not that this line is slow. We're just executing it a ton. And what I would love to be able to set, maybe we can figure this out. Let's take a screen cap of this. What do you guys use for your, like, if you have like a, like for this kind of question, how do I use this tool? What like AI do you prefer? Like which repo? Can we see the algo where they are written? I think I am lagging in TS circuit. It's in the capacity autorouter repo. Capacity autorouter. Although we're giving it a different name, but the name I am intentionally not announcing yet. But we do have a name for the new autorouter. Yeah, you're welcome to try to run it locally. There are issues on that repo, but I don't bounty any of the issues because how can I get the number of iterations instead of the time spent online from the Chrome profiler? All right. Yeah, I don't put any bounties on it because I think people would just like frustrate me. They would like do commits with AI and they would break things or something like that. I don't have enough regression tests where I think people can just run in and do stuff. But you're welcome to if it speaks to you. I would love contributors. I'm just like worried. I'm not going to bounty anything until like I know things won't break. Basically, the things that work really well for bounties are where there's a lot of tests or yeah, the it's really easy to prove that you did the thing. Like if it's like implement an API and the test you like have to call against that API, it's really easy to validate. But with autorouters, it's a little hard. There's performance implications and stuff like that. Oh, they want me to log it manually? What? Recording, check call tree, or bottoms up view. All right, let's try the bottoms up view. See if we can get this to work. Bottoms up view. Summary. Oh, they've got a self time, total time. I don't know what that means. Bottom up. They definitely have this number in here because like they have like all the data. They showed me all these blocks. I basically want to know how many blocks there are. Whoa, what is this? Oh, this is a bottoms up view, so it goes up from here. So looks a little weird. How many? I don't know if I'm going to be able to figure this out. How many times is this called? Event log, maybe? That looks maybe not the same thing. Call tree. Yeah, I don't know. I don't know if we'll be able to figure out how many times this is called. ChatGPT is kind of useless on this too. Maybe I need a smarter AI. I should give it to 4.5. Let's give it to 4.5. Why not? Oh. Okay, I'm going to paste that. Go back. Find my image. I don't know why I feel like this image will help the AI, but it's the way I feel. All right, 4.5. 4.5's got style. Bro, I'm not able to understand a single issue. I think it needs a fucking huge amount of time, like a week to understand this for me. Yeah, probably. Probably takes a while. Dude, I've been building autorouters for like 9 months. Most of the issues are just notes because I have to do things. But if some savant wants to come in and give it a try. Why is it telling me to measure it? That's so annoying. Console.count. Is that real? Console.count? Is that a real thing? What? What? Madness. Crazy. Whoever was working on console was really cooking. They added a lot of stuff that nobody ever uses, and I don't think they would have been added today. It's probably like, because that's like console is also a Java thing, so it's probably like back in the Java days, basically. Anyway, yeah, let's see how many times this is called. So we'll say get adjacent process nodes inner loop, and then we'll go back here. We'll rerun, lose our data temporarily. Console account feels like somebody told you this before. Wait, did you? Who told me? We're slowing down the program because we're logging so much. That feels n squared to me. What we're going to do is we're going to take the number of iterations and we're going to compare it to whatever is in the console. Assuming the console doesn't break. It kind of feels like it wants to break. Oh, jeez. All right. I am not loving that. Yeah. All right. So we'll do something else. We'll count the iteration count with a global. Is this all related to data structures and algorithms? I mean, it's a lot of... I think Ansh is looking at the issues. We can take a peek at the issues. Okay, so I'm going to do iteration count plus plus if iteration count modulus... I don't know. What do we want to do? 1,000 equals 0. We'll just do that. So you're looking at the issues here. What are these related to? Capacity path planning needs to penalize. I already implemented half of this. I mean, I don't think you would find... We're probably going to do a little bit of this today. Implement KD tree optimizer for obstacle segment collisions. You guys know what KD tree? KD tree, short for K-dimensional tree, is a space partitioning data structure. Yeah, there's like 13 sub-algorithms. And then, yeah. I don't know, dude. People are actually really bad at algorithms. If you actually need algorithms, you start to realize that everything sucks. Like nobody uses one of those things calls it multi-head A star or multi-agent A star. Basically, nobody implements that because it's too hard to think about. So like, so, you know, people, you know. Oh, wow. Oh, wow. I'm glad we stopped that because that was really slow before. Like, we didn't even get to like 300,000 or something. There was no time impact on that iteration count. So that's got to be n squared. Copy multi, what up? What up, my dog? Silly doubts. All right, so we got... So this function was called like 8 million times or something. Is that right? What is that? That's 80 million. Okay. And then we got 9,000 iterations here. So what is that as a function of the number of nodes? The problem is I don't know the number of nodes. Yeah, I don't know the number of nodes. So I guess I can't do like a proper n squared count, or what do you call it? Yeah, n order. What is that called? ON? What is the n? What do you... yeah, so each iteration, it's getting called on average about 9,000 times. So that's good to know. Why? You know, that actually seems pretty high. Each iteration is being called 9,000 times in that loop. Huh. But you are a pro at this. I guess so. I mean, do you know, like, pro means paid, and I do pay myself to do this. So, yeah, I don't work for free, you know. I don't know if it counts if you pay yourself. Actually, I didn't think of that loophole and the implications of it. Algos things. It's why we're here. It's why we're trying to develop a world-class autorouter. Employ those algorithm skills, which I do not have, by the way. I just force myself to do these things. All right. 9,000 times it's being called in here. You know, it's kind of interesting. So this is getting called You know what? I'm not done. I'm not done with these iteration counts. How many times is this getting called? Get adjacent same layer unprocessed nodes. All right. We'll call this iteration count inner loop. And then we'll create a new one, iteration count. So get adjacent. Whoops. No. Man, cursor gives me so many bad suggestions. I get it. Like, you're not supposed to just accept like crazy, but when you're doing easy stuff, you can accept like crazy. And when you're doing hard stuff, you're like, dude, that bug is going to cost me so much time. All right. Let's try this again. No, pro means good, professional. Professional literally means somebody paid to do a thing. So if you're paid to do a thing, then you're a professional. Congratulations. There is a certificate or something in the US, at least. Like, I think we have like professional certificates, but you know, it's more like a what would you call it? You know, it's not really that big of a deal. In computer science, we don't really have professionals, software developers. We don't have like, or whatever I'm talking about, like professional certificate or like engineering certificate. Like engineers need it like a special thing so that they can build a bridge that people won't die on. Like people care about them meeting some minimum requirement. But software developers, you know, that arguably, you know, in some ways have more, you know, how many bridges have you crossed lately? But all right, so get adjacent is called about once per iteration. It says 9,000, and this is 9,000 iterations, so it's called once. So yeah, this basically the number of nodes in each batch, which I think is the orange. If we watch this guy animate, it's quite high. 1, 2, animate. Yeah, it's all these orange ones. So this is quite high, and we're doing an n-squared check. So this is like a really obvious example of where you would want to use a KD tree. So a KD tree is basically like who's near me in a fast way. So I asked Claude to build me a KD tree yesterday. And it wrote a KD tree for me. So I'm just going to plop that in. You know, like if the algorithm is simple, you don't really have to do a lot of work. I am paid to do a backend project. I only had a few pet projects on Nest.js. Then you are a professional backend developer. I anoint you. Nest.js. I remember people advocating for Nest.js back in the day. I don't really know. Nest.js is very serverful, you know. You know, as opposed to serverless, it is very serverful. So I don't know how I feel about it. That's what I'm trying to say. I'm a big serverless advocate here. Client side and serverless, you know. I like things close as possible. Has any other company made this before? Yeah, there's a bunch of companies that make autorouters. Yeah. But we're going to be the best. The very best. Like no one ever was. All right. All right, I get the idea. It's slow. We need a KD tree. Let's do it. Let's do some hardcore programming. Closing out all the tabs. So let's remove our dumb console logging and whatever. Iterations. Let's also do a little, let's see, can I do a, yeah. All right, this is where this diff is like I switched the order of these lines to get a quick 6x gain. So let's commit those. Gain via line order switch. Yeah, when you have a loop like that, that's really expensive. Like the order that things execute is really important. So, and it's kind of counterintuitive. Like doing a lot of math is actually pretty cheap, but doing like memory access is really expensive. So, all right. So we need to convert this into a KD tree, and then we're gonna access adjacent nodes that way. So there's a couple ways to do this. I think what I'm going to do is in the constructor for this algorithm. So that the algorithm is composed of a couple parts. So you have your constructor, which is where you might initialize data structures. You don't want to do anything expensive in the constructor. And then you have this step function, and the reason this has got an underscore in front of it is because it's basically the internals of something that's wrapped in a parent class, which is just like a random class pattern. And a step function is going to set solve to true when we're done. But it's gonna do work, but not too much work. So one fun thing about algorithms, some of the first algorithms you're taught are recursive algorithms, but recursive algorithms actually kind of suck. They are sort of unbounded. They implicitly have a depth first search. So like if you're like doing recursion, you almost always travel like this, like in the order that I'm doing it right now. But a lot of times this is suboptimal. So, you know, a better order than that order would be like this. And then maybe you evaluate these two and you decide, oh, I'm actually going to go here. So, like, recursion is actually bad. And not a very important concept for algorithms, in my opinion. It's like sometimes you have to do some recursive stuff, but a better pattern is a work queue. Or a work queue with a cost per work item. So you're basically like, oh, what should I do next? You know, you're constantly, I guess a priority queue would be what it's called. So that we use priority queues for almost every data structure here. So there's no recursion, it's just priority queues. We decide what to do next by what is most important. This function is no exception. It starts with big nodes, and then it goes to small nodes later because it's less iterations if you start with big nodes. Let's create a KD tree. So I will say KD tree capacity mesh node or capacity node KD tree. Yeah, it's a relaxed KD tree. Which means so that this was implemented by Claude. I just gave Claude the data structure of the capacity node, which is basically like a center, width, and height. Do you ask this stuff in an interview? Not usually. No, I don't usually do algorithms questions in an interview. But if I was interviewing somebody to work on autorouters, I definitely would. I would probably ask in an interview, can you implement like an A star search, because A star is like the most fundamental of all the algorithms. I actually think A star should be called fundamental algorithm. That's my controversial opinion. I literally think it should be called fundamental algorithm, and because it's such an important algorithm. Let's see. Do we want to do it this way? I think what I want to do, instead of initializing all the nodes, this might be a mistake, but I think I want to, these are all the nodes that are relevant, that are non-absorbed. Because this thing is like, it's merging nodes, so it's like absorbing nodes that are next to each other. That's like the concept behind this sub-algorithm. So we're going to add each node to the KD tree. I have no idea if this KD tree will work. We're going to have to understand it in a second, because Claude is really good at implementing like very foundational algorithms, but yeah, we'll see. So now instead of going through each node, we're just going to get ones that are close to the root node. So yeah, nodes within distance of the root node. And then for the distance, we're going to do root node dot width plus root node dot height. I think that makes sense. It's basically like width times 2. That should give you all the adjacent nodes, especially because we go from largest to smallest. That should give you everything. Maybe I'll multiply it by like 1.1. That should work. There might be some edge cases where that doesn't work. But anyway, that is going to reduce our number of nodes by hopefully a lot. And then we want to actually go through the current batch. So what I think I'm going to do, say current batch nodes set, because we know that sets are way faster thanks to yo, what up, Com? How's it going? A star, I think God saves me. What? You know A star. Oh, I see. Yeah, you should be able to implement A star. That's pretty fundamental. I don't think a lot of U.S. students could do that, honestly, because the curriculum, and I don't know, maybe a lot could right out of school, but I don't know. A star is definitely the most important algorithm to know, in my opinion. It's like you should be able to implement it from scratch, and you should also be able to use it outside of pathfinding, because it can be used for so many things. Anytime you're doing an exploration, you can kind of use A star, and where you can't use A star, or you can only approximately use it, A star easily converts into a breadth first search. So I'm not going to talk about A star too much here, though. Yeah, let's go through nodes within distance. Is this a node ID? No, it's a whole node. So we'll do this. We don't need to do that. So we're going to say if it's not in the current batch, we're going to continue. I think we've handled all the cases. Let's do it. I know Mango Tree. I have no idea what you're talking about. The things I hear in chat. Let's see. Are we faster? Are we slower? Does it even work? Yeah, all right. So that's a 2x gain. Let's see if it actually worked, though. It's kind of hard to tell sometimes. One did the board route. It kind of looks like it worked, though, which is kind of crazy. Just a quick 2x speed up. I mean, board looks fine. The routing looks fine. Let's look at the node merging step. So I believe that's this step. Looks pretty good. No, that's, I don't know what step that is. I think this is the node merging step. It's kind of hard to read, though, because it's multi-layer. That's why you've got, like, 2 boxes. But this looks right to me, I think. It's definitely tough with the multiple boxes. It kind of looks like... Yeah, I'm not sure. Oh, yeah, no, that looks right. You have to like mentally separate these different boxes that are the same color but are on different layers of the PCB. But I've written it in Python. You should be able to implement it in any language. If you know A star well, you should be able to implement it anywhere. Yeah, I think it's working. That's crazy. All right, let's do our performance profiling. That's crazy, though. That was a 2x speed up. We didn't even do anything. You know what's sus is it took more iterations, so that's pretty suspicious. Our iteration count with the original implementation was like 9,000. So that means that we probably broke something. Let me multiply this by 3. I don't know how much that'll slow it down, but like We want to make sure we're getting all the nodes. Oh, you know what it could be is the node order is not as predictable anymore. I didn't think about that. It's actually hard to listen at 2.5x speed. Hey, dude, nice to see you. I thought you'd never come. Yo, what up, Rohit? I'm here. I'm here doing the thing. I still exist in the void, you know, because I'm tweeting, you know? The day I stop tweeting, then you know something's wrong. Then you know the prodigal son may not return. That actually makes sense. So it might not actually be this part as much as yeah. It's probably we might as well try it, but like yeah, the algorithm is a lot less deterministic now. I do like a deterministic algorithm, so maybe yeah, I might need to sort the results for determinism. I don't think sorting is really fast. I don't think it'll cost us too much. Yeah, we're 10,300 again. So that makes me think it's an ordering issue and not a... Okay. So the tricky thing is, this is why premature optimization is so bad, because like now I'm trying to think, all right, I want the behavior we had before. It was less iterations. It was better. I think it was merging bigger nodes first. So I think we need to sort these nodes within distance. It might not be that bad. Let's sort based on size. Somewhere else there's a sort function. Let's see. Yeah, it's basically just the area. Width times height is area, right? Okay. Let's try that. See if we get the iteration count back to our deterministic. At 3x speed, it becomes insane. Are you talking about me or? We're still at 10,000. That's pretty weird. Why would it take so many more iterations? It makes me think that the results might be different. I don't like that our optimization is changing the behavior of the algorithm. I also hate this visualizer. Like, it's so hard to read. Let's make this visualizer slightly better. How are you, buddy? I mean, you know, as good as I can be. I did my taxes, which I'm quite happy about. But look, I'm not happy until TS Circuit is the #1 way to build electronics. So that means I'm going to live a long and miserable life until a moment of happiness at 40. What am I doing? We're trying to optimize this algorithm that handles auto routing. So the wiring of circuit boards. And we're trying to make the best one in the world. A couple companies reached out to me and were like, hey, we saw you're trying to build the best auto router in the world. You don't stand a chance. We're going to give you access to our like private auto routing algorithm. Like you can like use that as an API. And then you can, when you do benchmarks, you have to use us. And I'm like, all right, I guess so. Got me there. So I'm pretty excited to try out some other people's. Yeah, it's gonna be pretty cool. Unfortunately, I can't like live stream that or announce that because they want me to keep it under wraps. But I'm very excited to show off some stuff there when I'm able to. We need a gaming stream for a change. Wow, I come online after months, and then people are immediately like, "What's with this programming nonsense? What is going on?" Yo, Tech Man, what up? What up? All right, so I'm hung up on iteration count. Let's just let's revert this temporarily just to look at. So if you guys ever need to revert stuff, great way to revert is just git stash Aruni. So we've reverted our change here. Let's take a stare at this real quick. Why? So we go through the current batch, get each unprocessed node, and that's the order we process them in. And when I do this, I hate how long this takes to run. I'm like always waiting on this to process. All right. 2.61, 9,000 iterations. Wait a second. 2.61, isn't that what we were... Hold on, let me refresh. We might have gotten fake gains. This is only 1.45. Maybe I think I changed the circuit I was benchmarking or something. Live after a very, very long time. Amazing. Thank you. Thank you. It is amazing for me to press that button and share my screen. It's basically like I'm on a Zoom call. So I appreciate all the people being very nice about my ability to press that button. I'm just gonna benchmark this a couple times so I understand. All right, I think 1.41 is the score to beat. Let's go to a bigger board. I don't think I trust. Oh, this one won't work though. Maybe we'll see. I think this board takes too long. It's gonna like freeze my computer. Let's do this. I think it takes 50 seconds. I think. Which is too long right now. That's why we're optimizing. We still need a gaming stream. What would I game? Maybe if somebody says something that is very appealing to my my hind brain. All right, we're gonna manually do this. Diablo 4 is discounted. Is it really? Is it really? Interesting you say that. I was just about to have a productive weekend. Diablo 4, $30. $30. I'm a discount bin gamer. You call that a discount bin? I don't think so. I think your live is a lucky charm for me. Whenever you come live, I do more and more bounties and PRs merge. That's good to hear. You have a PS5. I don't have anything. I have a PC. I have a RTX 3060. From 50, what can I say? I would love to play Diablo, actually. It looks really fun. Looks really fun. I am currently doing Baldur's Gate, actually. That's my current. I'm not gonna stream that. I feel like the audience would die if I had a live audience when I said that. They're like, oh, I don't want to watch a friggin' Baldur's Gate stream. But I wouldn't stream that anyway. It's too fun to play solo because you're like, you know what I mean? You're like, oh, what do I say? Oh, should I reload my save like 20 times to try to get this random thing I don't deserve? Maybe buy a PS5 to try the GTA 6 hype. Buy a console. You know, this went from a playful idea to an expensive idea very quickly. All right, so we see we have 22 seconds on this old method. I'm going to get on the stash or get stash pop. Let's see how much time it takes with our KD tree. I'm like slightly bewildered right now, so. Ooh, everything takes so long. Sad. I do like GTA. I'll probably play GTA 6 at some point. I don't know if I'll stream it. It's a lot of effort. People like assume if they like me when I'm programming, they'd like me as a gaming streamer. I don't think so. I don't think so. You know, might be like really, really bad, you know. I guess, you know, I don't really game with friends or game much in general, but I'm assuming people have like a friend who they like in real life, but then when they're gaming with them are like the worst. I got online with one friend the other day and I was like, man, I'm like not pulling any weight at all. Like, and I don't know what's going on, you know, it's like probably not super fun to play with me. I'm just waiting on these iterations. Told you, algorithms. It's weird stream content. Factorio and build fastest auto routing there. That's a good idea. See, that's a good idea. Mr. Comp gets points for best idea. Yeah, I like Factorio. I haven't played it. I haven't beaten it. Haven't played it very much all the way through. But there are a bunch of people doing, you can program Factorio. I would love to make a React fiber layer. Is this even running? What is going on? I would love to make it so you could program Factorio in React and then run a bunch of stuff. What is going on right now? Is it like totally frozen? Man, this KD tree sucks. I think this KD tree is taking longer than the normal implementation here. Let's wait. Let's get the data. Let's not make a judgment call. Nah, you're cool to game with, I believe. Thank you, Unknown Traveler. Appreciate that. Let's play some cooperative solitaire. 18.68. So I don't think our KD tree is working. I'm also getting pretty annoyed that I have to like come and click around. So we're gonna do a dedicated fixture for this. Yeah. 18 seconds is a little bit of time to wait. So I think we'll do a dedicated fixture with this one. So I'm going to hit this button a couple times and then we can download the input. We're going to use this download input button and then we're going to make a page dedicated to monitoring the performance of this guy. So download input. What's this doing? Go to the old file explorer. You know him. Can't believe the KD tree is so slow. It's crazy. There's a lot to debug still though. So there's like a lot of, we're really only getting started. That's my point. So we're going to drop this in as an asset. Yeah, single layer node merger. We'll call this single layer node merger 2 because I think there's already a different one. Ooh, hold on. Do we have a task? Node merging. All right, we're going to rename it. Node merging 2. So we're going to create a test fixture for this. Ooh. You know what I would love? I bet this feature exists, but how do you collapse all in VS Code? Oh, is that what this does? Oh, yeah. That's awesome. Node merging 2. My favorite way to profile is to have a graph that uses local storage so you can just see what the last value was. You don't have to remember anything. So we might do that. Why is this erroring? Node merging. I don't know, maybe I have to do 0, 0. Something like that. What type does this expect? Ugh. Capacity mesh node array. I don't know. That seems right. Let's see if it works. Let's ignore the type. Yeah, there we go. All right, so it should show us the time. Yeah, 4 seconds. Yeah, I kind of want a little graph of those times. Maybe at the bottom, we could just put a graph of the times. And then we'll have a little bit of an easier way to measure this. Let's add on solver complete. What was your first company you worked and what was the paycheck? I don't know. That's a tough question because I was doing stuff since a very, very young age. Very, very young age doing random stuff on the internet. Like, arguably, my first money ever was I won a competition for making a game called Big Island, which I think is still around, maybe. Big Island. And I got like $1,000, which 20 years ago or whatever was actually maybe 15 years ago. Big Island game is going to be there. Game HTML5. Oh, wait. I think this is it. Yeah, this is it. Ooh. Site's offline. Oh, I should bring that online. Oh, wow. Went offline. That feels bad. Wait a second. Is it really offline? All right, whatever. I'll figure it out later. But yeah, I got $1,000 from Mozilla for making an HTML5 game when HTML5 games were less of a big deal. But I liked HTML5 games because everybody was building Flash games, but I had a Linux computer because I had too many viruses on my Windows computer. So it was always breaking. So I used Linux to avoid getting viruses. And Flash, the development tool, didn't work on Linux. So I had to use other things. Play Mincecraft? Never heard of Mincecraft. Mincecraft, like mince to meat. What is that about? Mincecraft. Very interesting. You know, I don't keep up with all the gaming trends. It's hard for me to know, you know. It's like a top-down real-time strategy game, right? Mincecraft. Where? All right, what are we doing? Solver completed on solver start. You know what? Let's just get Claude to implement. This is easy stuff. Implement on solver started and on solver completed. Have you heard of Valheim? Yeah, I like Valheim. I like it conceptually. I played maybe 8 hours of Valheim. Yeah, it's pretty fun. I actually buy a lot of games. I would be like considered a whale, I think. Maybe not like a huge whale, but I mean, I probably spend like $500 at least in games every year. But I don't play them because I get bored. Yeah, play some Valheim. I like Valheim. Yeah, I don't know if you know my Steam username, but DM me on Discord and I'll send you my Steam username. All right, did it implement this properly? Looks maybe right. What is this? Use effect, check if it's completed. Nah, it's bad logic. It's bad logic. Maybe it's okay. I think I can make this better just by saying main solver.iterations. So that's never recalled. Yeah, other than that, it looks pretty good. It looks pretty okay. I hate how it adds things to use effect. You want to keep your okay, everybody's wrong about use effect. You want to keep your dependencies super small inside use effect. It's not about having everything. It's so dumb. It's already called here. That's madness. This is dumb. This is a bad implementation for the most part. Like, if you're already handling it in a use effect, why are you handling it everywhere else? Oh my gosh. Oh, garbage. Oh, it's such garbage code. What are they doing? Oh my gosh. Garbage. You handle all of this in a use effect. Why do I even talk to you on solver start? Wait, this one might be good. What are you talking about? What are you talking about? Oh my gosh, AI. I get so mad. Because it is like the ultimate junior developer, you know? Oh my gosh. Garbage. Garbage. That was a lot of garbage to process. All right, let's see. Reset solver. That's wrong. You know what I could do? I could simplify this even more by just saying, if you're on your first iteration, we're going to call, well, no, that might not be reliably called. Screw AI, yeah. AI sucks. Taking our jobs. It's just like I don't know. I'm going to reject the whole thing. That was terrible. That hurt me. I lost brain cells on that one. Okay. We do this from scratch now. I did like its idea of using a use effect because I don't have to think very hard about it. You know what I'm going to do? Here's a good idea. Here's a good way to do it because I don't care at all. If it's greater than 0, nah, I can't do that. Maybe I can actually. Let's do this. Main solver.iterations greater than 0. If main solver.iterations is greater than 0 or is equal to 0, return. Otherwise, if on solver started, call on solver started. Easy. Because this is only going to change from true to false like once, you know, or whatever. Okay, the other one we'll call each time, and we'll say if main solver dot like finished, solved, or main solver dot failed. Yeah, I guess we could consolidate this a little bit. Oh, actually, I guess it's an and, so we do this, then we do that, then we do that. All right. Cool. That should do it. Red color always hurts my eyes. Seeing red brain be like error. 100%. 100%. I don't like errors either. I agree with that sentiment. Oh, it hurts me how slow this is to load. Okay, but what are you going to do? I should probably convert it to canvas. All right, so we didn't actually do anything with those events we implemented, so we're gonna make this a little more complicated. Return. And then we're going to give it some... We're going to track with the local storage. Okay, this one I'm going to try to use AI for too. On solver completed. Track end time. I want to track the start and end time of the solver and put it on a graph with recharts. Save each time it runs in local storage, each time it completes in local storage. Store the duration. And put a graph under the generic solver debugger. Add a clear button so I can erase local storage. All right, hopefully it does better. Everything's a little dumber when you do it through cursor. I'm just going to say it. I feel like I don't have as many allies because I just shit on everyone's product that they work so hard on. But yeah, cursor. I don't know. If you want to reliably get AI to do things, like there's only one game in town. It's Aider. Because you know exactly what's going into context. There's no like futzing about. You can also, like, I've gotten probably the best results by doing a repo mix, which is CLI/website. So I do a repo mix of a directory or something, and then I upload that to Claude. And that probably gives me the best results of any method. But I don't know if we'll do that. Maybe we'll do it. Tooltip. Oh, annoying. All right. Let's just see if it works. It's probably not going to work. Yeah, I'm glimpsing an error here. Oh, maybe not. Clear history. No solver runs recorded yet. Seems okay. For some reason, this started like focusing on hover. And I have a suspicion because somebody did a PR recently, and I think they added that feature, which fucking sucks. You know what? It was whoever did this feature. Sorry, that's driving me nuts though. Man, and it drives me crazy. Like, I get it. Like, contributors don't use like all this stuff day in, day out. But man, when something annoying comes in, it's like, dude, I'm dealing with that. That is like, I breathe this thing. Do our API key have a limit? How many chats can I use? You definitely have limits. I don't know what they are. Don't overspend them. Don't, like, yeah, I don't know. I don't even know. I think people should probably pay for their own AIs, is what I'm starting to think. Like, everybody gets bounties and sponsorship and whatnot. It's like, why am I also paying for this? Because some people spend, like, so much money. I know people see me in my bathrobe. They think, oh, this guy is probably some billionaire, you know? But I assure you I'm not a billionaire. I am sub-billionaire. I should add that to my bio. Sub-billionaire. Anywho. Right. So somebody, I think, probably added focus. Yeah, what the fuck? Oh my gosh. It was whoever added the dimension overlay. Dude, fucking murder. Oh my gosh. Dude, ruined my life with this. Oh my gosh. You gotta be kidding me. We had a whole discussion about how much I fucking hate this feature. Jeez. Oh my gosh. Oh, I need to read PRs more carefully. What is... I can't believe this. I can't believe this. Oh my gosh. Sorry to whoever implemented this. I don't remember who, so yeah. But I gotta live my life, you know, with emotion. I don't even think any of these are necessary. These are literally not necessary. Yeah, people just copying implementations. Nonsense. Maybe it's okay. God, it's so annoying. It's everywhere. Focus on hover. Jeez. That is so annoying. Oh my gosh. It's like they had an old version of a repo. Am I a millionaire? Well, you know. Paper millionaire. Let's just say I've got my hands in a couple equities that have a dubious market value. No. No, when you do startups for like 10 years, you either are obviously a millionaire or obviously not. So I think I fall into the latter category. But you will for sure become a billionaire. Then we people will become a millionaire. I think Ayush did this. I don't even know what that means. I don't even know what you're talking about right now. Everybody gets very rich over time, though, is what I've noticed. Everybody's life generally improves, so stick it out. Remove focusing. I seriously can't believe that somebody. I guess like people don't have eyes on like everything I'm reviewing and stuff like that, but it was such a big deal that like the PCB viewer was doing this focusing thing, and then we finally got rid of it, and it was like paradise. All right, anyway, it wasn't that hard to remove. Hopefully I didn't break anything, though. I'm not really testing. Remove container.focus. Oh, such a wreck. I think probably at least 8 people worked on PRs to remove it. Maybe not 8. At least 5 people worked on PRs, and nobody was getting it. And then finally I had to fix it, like I did just now. But I was only able to fix it because I knew exactly what was causing it, because we already went through this. All right, so we got to check to make sure that zooming and... I think the D key doesn't work. So that was apparently kind of important. What was your expensive purchase? I don't even remember what I said 20 minutes ago. So Ayush with your focusing. Apparently it was necessary though, because the D key doesn't work anymore. So I have to figure out how we solved this originally. Look, guys, Ayush is doing his best. All right, don't get mad at Ayush. He writes good code, but this is quite annoying. Well, a lot of stuff doesn't make sense here. For example, using a ref in a use effect dependency makes no sense. We could try to do container bounds. That makes more sense. So like on window resize, you attempt to rebind. Makes like some degree of sense. Yeah, there we go. The use effect, if you put a ref into a use effect, it's never going to be run. Or it'll be run like once before that ref is even instantiated. This one doesn't work for some reason. I think maybe it only works inside the iframe. Yeah, it only works inside the iframe. What if I resize? Yeah, I'm not sure. But I think that might be more of a storybook thing. I'm not sure. Or whatever this is, this environment. Oh, it doesn't work in an iframe either. It's like super... Yeah, now it's waiting for resize. So what we really need... How is this fixed in the PCB viewer? Man, dude, I hate to be working on this stuff. Not to, like, give people too much gripe, but, like, I didn't want to do this issue. That's why I bountied it, and now I have to do it. I'm just complaining. But D key no longer works. Open last month. I think this is fixed. Let's see. It's like an endless hell, this F and D key. Wait a second. Does it just not work in here? What is going on? So I guess they have the same issue. Seems to work a little better. I think it doesn't work inside this that environment because of the iframe or something. Why you stop putting bounties on issues? Because I've been focusing on other stuff. But people can create issues. Just create your own issues, right? But like if they're web issues, I'm probably not going to bounty them. So the best way is just to create circuit boards. Why you did this to us, Ayush? Yeah, that's how I feel. That's how I feel right now. Yeah, there's so many issues. Like, you know, people should just... Honestly, people should probably try to do more with the sponsorship system. And instead of doing bounties, which I usually bounty fairly hard issues, just like fix things you find and you'll have like way more PRs, and then you can fall into the regular sponsorship sort of regiment. This one uses container ref, which is pretty weird. Saturday stream. Let's go. I am all about the Saturday stream. What up, Peely? This does do focusing. Interesting. This is kind of interesting. I want to try something maybe a little bit jank, but this is kind of contained here. So let's say if I call this a function like rebind or bind keys, and then what if I just made it so that like on mouse enter, which is a very like normal time to do things, we just do a rebind. Fuck. What'd I call it? Bind keys? All right, let's try that. Can't believe how long I've been dealing with this effing bug. Still doesn't work in here. And it doesn't work in here until you resize. It's like that on mouse enter isn't getting called or something. It almost seems like the container ref isn't being updated. My sponsorship gone like crazy, trying to bounce back. Crying face, crying face. Look at all this like text it inserts, dude. I guess emojis don't come through. I'm on top of the charts, but now crying. Just build boards. Everybody should just build boards. Just gonna debug this for like 5 seconds. I kind of wanted to do algorithms though. We haven't made much progress on the algorithm front here. That's so weird how it's binding. That yeah, that's getting called a lot, and then it works. What about over here? So the binding is being called. I don't know. I think the D key might just be captured by the test fixture. So it's like not really a big deal, I think. Add bind keys to on mouse enter for dimension overlay. I think that's a pretty good pattern. Just rebind when somebody puts their mouse over. There's no harm in that. All right. We'll merge that and then go back to algorithms. I think live stream distracts you from your main goal. I don't know. I think in this case, a bug distracted me a little bit more so, but it does happen. It does happen. This guy, where were we on this? So we wanted a graph to show how long it's taken historically. So if I run that, it's solved. There's no graph. Unsolver completed, handle, solver completed, start time. What is this? I would use a ref for this. Yeah, like that. If like you don't need re-renders, just use a ref. Handle solver started. So we'll say that. And then, yeah, that should work a little better. Because I think like just the way re-renders work, it's not getting updated in time. I think you need a person who takes charge of chats and you just code. I don't think that would work. Where you just live stream without talking to the chat. sounds like a not good idea so far. I think you need the feature of adding negative Algora bounties. How about that? Yeah, punishing people for contributing. Now you're talking my language. Now I'm listening. All right, let's do a solve. Let's see what we got here. All right, it's got 2 points. What is it, like auto bounding this? Man, this is garbage land. What is it saying 0 for the run? And what is this? Set durations. It doesn't even store to local storage. If stored durations. I guess that works. This guy is pure chaos and I fuck with it. As you call them, sabotage PRs should be punished. I do like that. I decided to change the terminology recently though. I'm going to call them WTF PRs. And then cuz sabotage is aggressive, and what I've noticed is there's some people who are so bad. I want to punish them, but I feel bad calling it sabotage because they actually do seem like they're like messing up that bad. So so I'm just going to call it a WTF. But yeah, we're going to have a /WTF command. Or maybe I'll just detect every time I say WTF in comments. It's also shorter. A couple people have freaked out when I said sabotage. They're like, no. I'm like, all right, fine. We'll do WTF because in any case, I am saying WTF when I read your AI slop code. It's like it's not calculating this duration properly. What might be happening is because it's executing synchronously, date.now might not work properly. Either that or the graph's wrong. So only one way to know. Let's log it. Oh my gosh, this is so slow. I think you were talking about me. Crying face, crying face, crying face. Dude, you take up so much text with these emojis, dude. Do you see this on stream? It's like the whole stream is just here. The crying faces. Yeah, of course. What you said. Sure. Whatever helps you sleep, Anch. Yeah, duration 0. Interesting. So even though it's taking 4 seconds, let's try, there's another API called performance.now, which I think doesn't suffer from these issues. Let's try that. It's like date now, but it's more performance-y. That's my understanding of it. Still 0. It's definitely not taking 0. It's taking 3 seconds. That's interesting. I've never seen a discrepancy that crappy. Either that or maybe onSolver completed is actually being called too early because we did just implement that. Oh, yeah. I need to say main solver dot iterations greater than 0. Wait, but this should cover that. I'm not so sure. Oh, let's log the number of iterations when it decides that it's done. I don't know, it could be a bad use effect, but then you would think it would be called multiple times, so I'm not sure. So many possible sources for this simple error. Yeah, it says 10,000, so is it this one that's being called too late? Should be 0 iterations when it's called. Oh, now. What is that? Duration 0.1. Solver started 10,000. Yeah, so, okay. So handle solver started doesn't really work because I think... yeah, it doesn't work. I think the problem is after a React render, because it's all executing synchronously. After that React render, it's like off and away. So we will manually call it in a couple places, like here. We'll call it before the solve. You know, I really only care about that one case, so we'll just leave the bug in there where it doesn't work for other cases. There we go. Yeah, all right. That is all lined up now. Cool. 3 seconds. All right, so let's clear that history, and then we'll try this again. We'll do a couple runs to benchmark this algorithm where it is. I think I might revert the KD tree. We'll see. Okay. Oops. Let's rerun. I guess there's a reset button, so maybe I should use that next time. All right, we're getting some data. Okay, we've got 3 data points. It takes about 3 seconds. Yeah, last time this was kind of an issue because it seemed like the timing was changing on us. What would be your dream company to work with? Do you mean as a customer? Like be hired? If I wanted to be hired for a company, I would probably apply to said companies. Yeah, there you go. Ethan's got it. It's much more eloquent. Hey, if you were a wage slave... I'm just kidding. A wage slave. That's a very politically loaded word. All right. We've done some stuff. Let's do a commit. I'm really unsure about the KD tree implementation, so I think I'm not going to commit that. I think I'm actually going to remove it and see what the times are. All right, cool. Record timing in local storage for solver runs. Yeah, cool. Okay, so we're gonna do get stash again to revert our implementation of the KD tree, and then we'll do solve completely, and we'll see if the timing is much different. It looks faster, 1.85. So that kind of implies our KD tree was actually crap. I actually find that, yeah, 1.8. Yeah, our KD tree sucks. Yo, what up, Rashab? What up, Complexity? How's it going, guys? Welcome. Yeah, so these 3 are the KD tree, and these 3 are what we had before, where we iterate over everything. We can see the KD tree is worse. I actually find this is very common. All right, unknown traveler, you've been here. I'm not going to say hi to you. Feck off. Anyway, I'm just kidding. Yeah, so the KD tree doesn't improve it. I found this is very common with theoretically robust objects is sometimes there's so much like effort to like sorting it. This is why I don't like quad trees. I specifically don't like quad trees because they split everything into 4 pieces, and I forget what's ChatGPT. What's the idealized version of what's a quad tree but with more than, it might be a KD tree. What's a quad tree with more than 4 sub parts? I think that's the data structure we actually need. Yeah, an N tree. Oh, it is a KD tree. Yeah, so I think this KD tree implementation, it's basically like really bad. It's like a quad tree, but it divides each layer by axis. So we basically it's not good. KD tree. Oh, it's a no. KD tree, a binary partitioning scheme. We don't want a KD tree. Yeah, because it's always binary. I didn't know it was always binary partitioning. That's interesting. I switch back and forth. Depends what I'm doing. I like Claude the most, I think, if I had to pick one. I think Claude can do smarter things, but I use ChatGPT for like a lot of stuff. All right, so how do I want to do this? Yeah, so of course the KD tree is going to be kind of crappy because it's probably really deep. The KD tree. It's like I also think I wasn't removing nodes from it, but removal from a KD tree is also quite slow, so DeepSeek. I would use DeepSeek, but you know. It's a lot of services and it doesn't add too much over like Claude. I would say if you have Claude, you don't really need DeepSeek. I like DeepSeek though. If I was running DeepSeek myself, I'd probably like it quite a bit. Multi-level grid tree, spatial subdivision tree. Why? Yeah, generalized N tree. Let's go to my original prompt for the KD tree, and we'll revise it to give us whatever the hell they just called that. What'd they call it? Generalized shit. Generalized N tree. Aha. Rebalancing KD tree. I feel like this one I already started with an implementation, so I need to find the original request because it had a nice prompt. Man, I did such a long prompt the other day and I lost it. It was the worst. Oh my gosh. Oh, look at all these asks for algorithms. Some taxing issues, reporting CEO salary on a C Corp tax. That's funny. Oh man. Yeah, I was using bean count for accounting. That's super fun. Exclamation mark socials. You think I have automation set up? Just go to x.com/SeviIbar. That is the only definitive source of news in the world. I don't know where I implemented this thing, where I got this original implementation, but I guess we're just going to have to redo it from scratch. Leaking AI chat history. I don't think I really asked for anything too controversial. You guys are basically seeing me at my in my, natural state. All right, so I bet I used Aider to generate it. Oh, you know what I did, maybe? All right, I've got an idea. Okay, so I'm going to assume at this point our KD implementation is bonkers, and I'm going to delete it. I'm doing that very intentionally because I want I'm going to do a repo mix style prompt. You guys are going to be like, whoa. All right, so remove KD tree. Yeah, all right. And then we'll do repo mix lib. And what that's going to do is give us this big text file, which we will throw over to Sonnet. And then I'm going to say, please implement This is going to be our main focus for a bit. So please implement, what is it called? A generalized entry that allows the quick, try GitLab, it's fun to use. I believe it. I mean, I just don't have like the luxury of changing version control systems every week. I'm trying to get shit done, man. Look at you on your high tower, changing version control systems. Come down to Earth sometime, all right, unknown traveler. Why is my camera? Yo, camera. Please implement a journal that allows quickly finding nearby capacity mesh nodes via node tree dot get nodes within distance. Node distance. Yeah, I'll say as a class. Well, my camera is bonkers right now. It's moving on its own. This is going to take a while. This is going to take like 2 minutes. So what I did is I put the entire repo into context. Oh, wow, it didn't take that long. I guess it takes longer when you turn on thinking. All right, spatial tree allows efficient retrieval. You know what I hate? This is just like annoying about Claude. Like, how the hell am I supposed to read those? Within a specified, and you can't full screen it. ChatGPT has full screen. This implementation uses a quad tree-like approach, but generalizes to n dimensions. Ooh, I don't know if I wanted to generalize to n dimensions. I wanted to generalize to the size. Let's see. Compute bounds from nodes. Okay, all this is fine. So it's calculating the bounds. Build a tree, spatial tree node. Insert node. All right, how does it... Find nodes in area. Okay, find nearest nodes. I'm trying to figure out if it's going to have the same problem as before. Like, before the problem was it was a binary thing. So it was like a really deep tree. We want a less deep tree. That's what I think the problem was. Spatial tree node, children. Yeah, it's got children. Arbitrary number of children. That's good. Oh my gosh. They're trying to integrate it everywhere. Just let me read. Bounds overlap, subdivide. Ah, nah, see, it's a quad tree. Is this going to be better, though? Oh, maybe it works. Specs. I'm on a MacBook. I guess I'm your bot. Yeah, I don't really know how to do stream automations. It's like level 1 streamer over here. All right, let's throw this in a directory. We'll see if we can get some kind of improvement here. Let's see. Single layer node merger. I think they called it like a spatial node tree or something. Paste. They called it a spatial tree. feel like it's a little redundant, you know. We already know nodes are spatial. It's kind of a domain in this domain, you know, but sure. Whatever you want, AI. All right, we got a nice long implementation. I like how it has max nodes per cell. It makes me think that I can, if I set the depth to like it might be a decent implementation if I set the depth pretty low. Basically, the number of nodes and the max depth, the performance of those are super connected. Like if you set a max depth too high with too few nodes, you're not going to get very good performance. And you get like twice as much performance each time. So you definitely don't want to set the max depth too high. I think 10 is probably too high. Without running this, I'm even going to maybe set it to like 3. Because that's like an 8x performance increase for the number of things you're examining, in theory. Maybe we'll do 4. Just keep it closer. Yeah, max nodes per cell. I don't know if that I really care to be low. I think that can be higher. I don't know. These are a little confusing because these kind of can't go together. Let's keep it at the defaults. I don't know, maybe that's like a well-studied thing, and then we'll revise it. But I think those numbers are probably not great. And then up here, we're going to create our spatial node tree. So we'll say, yeah, sure. Spatial node tree, import. Yeah. Do I have an add method? How's this work? Build tree nodes. Oh, it wants to build them up front. Yeah, it's a little tricky because we might want to remove nodes. Not really sure about that. Yeah, I'm thinking we probably want to remove nodes over time. Ah, man, I don't know. Let's take a look at this. Yeah, it wants to compute the bounds and whatnot. Insert node. Oh, it does have a remove node function. Yeah, all right. This implementation kind of sucks a little bit and bothers me. So let me just adjust this. Node with area. Yeah, nice. Okay. Node. Yeah, there we go. Just a little performance. Just a little tweak. And that means I can build my tree a lot easier. I can say node with area, that map. All right. Okay, let's see if that does an error. It's not going to do anything yet, but it might take forever to run the constructor. I think the reason this page lags on initialization, or at least it was lagging before, was probably because of the constructor. All right, so no effect. That is correct. We're just not erroring out, which is good. So now we need to incorporate it here. Okay, so yeah, we'll do something like that again. I'm going to comment that out. Const node of nodes within distance. So now we need to make sure that it's in this this array for the current batch, because that's the logic we removed. So current batch IDs includes this ID. We'll keep that pretty like non-performant for now. That's a pretty expensive clause. So actually, the lower we move it is probably the best. It's probably the worst performing because this is an array. So hopefully that works. Yeah, if you have something that if you have a bunch of conditions, you have one that performs really poorly, you move it to the end. Easy peasy. All right, let's see how we do. All right, wow, 0.65. So that's pretty good. 0.65. Still not. Like, I really want this to be like 0.01. Like, I really want it to take 0 time at all. But let's run the benchmark because that's pretty good. How many iterations did it take? We got this 10,346 thing again. So, like, I really need to keep that old implementation around just so I can, like, yeah, let me do that. The fact that the implementation is changing each time makes me, like, pretty nervous. It's like, what am I doing? Am I breaking something? All right. So we're going to paste in that old implementation, comment this out. Like, the iteration count really shouldn't change. I'm also, like, trying to see from an appearance perspective. Does anything look different? It's also important. 9033. All right, so 9033 on this one, and this is what it looks like. All right, let's see if it changes. This is impossible. It's a great place for visual snapshot testing. It's actually, like, perfect. A visual regression would show this right away. And then I could see if it actually mattered. Yeah, this looks way different. Something's wrong. Does it? It's actually kind of hard to tell. I can get maybe... It's like all these straws here. Does that make sense? Yeah, I think something might be up. I'm not sure if it's supposed to be this. I'm going to have to take a screenshot. Let's do a before and after. We, we got to be very Hippocratic oath about this algorithm. Do no harm. All right, let's close some tabs. Too many tabs. I do suspect this is much different. It's hard to tell which one is right. So the whole point of this sub algorithm is to, like, merge nodes together. So the theory is if the nodes can be, and it only merges single layer nodes. So, like, these blue ones, it's definitely way different. It's definitely way different. Yeah, I think there's, like, a bias that's not working as well. I think it's very sensitive to different biases. So it's like neither. I think it's possible neither are wrong, but let's make it consistent. I like having the original implementation up there. That's helpful. Okay, so what I can do is I can say nodes within distance is a new set. Make this more like a... So we'll map that to their capacity. Okay, node ID. We'll say close node IDs set. And then we'll go back to the original logic for this loop, but we'll say if it's not in that set, we're going to continue. And then we'll do the in-memory retrieval. I think it's like node map.get. Something like that. Okay. So this is like more of a smaller optimization now. We're still going through like massive loops each time, but we're trying to get out of the loop before we do like this retrieval. And this is like smaller memory. I don't know. Let's find out. Yeah, we're not really saving any time. We're like back. We're even worse than before. Oh, this is getting me worried. This algorithm isn't supposed to be like a very time-consuming one, but yeah, that's basically worse. I think you have to reduce the number of iterations. I have like another idea for this that's pretty complicated, but like since you're like merging nodes each iteration, you could compute an adjacency matrix or like, you know, basically say on each node, hey, I'm next to these nodes. And then every time you merge, just kind of like add in the neighbors. And then you can just iterate over the neighbors of the node instead of like recomputing the neighbors each time. And that should get us out of n squared land. I think that's probably the strat. Because we need, like, even if we got to 0.72, we're not really in a good place. We really need to be like, pretty close to 0. It's got to be a 10x increase. Will your router biodegrade each time you do a firmware upgrade like Palo Alto's? Because having to diagnose, create, and work around each time you build is really, really good for job security. This is a crazy question to me. Biodegrade? Are you talking about like... This is an auto router, not a like physical router. Physical router is like a computer. It's more like a computer. This is like how you wire together things. I'm not building the greatest router. I'm building the greatest auto router. It's kind of a funny mishap. Yeah, that does. It does sound like it sucks / is great for you. That it's breaking all the time, I guess. All right, I'm gonna give this implementation like, I don't know. I'm gonna give it. I'm gonna try to do it. I'm gonna try to do it. And we'll see how it goes. So let's remove the spatial tree stuff. I'll just stash it. Re-asking on Twitch. Dope project. Did you ever peek at the freerouting.net implementation? You know, I haven't, but I have used freerouting.net a lot. I've seen okay, that's not I don't think that's what you I think you were talking about free routing. This one, freerouting.org. I've used it. I don't think they use the same techniques because it's a rip and replace auto router, and we are more of a not that. Use a different technique. Some of the sub algorithms are the same, but we use a much different technique. Yeah, I don't know what to. I have a name for our technique, but I'm only gonna reveal the name upon release of the router because there's gonna be a paper. but we use a different technique. All right. Adjacent node. Like, I don't think they have all these nodes. Like, what we're dealing with right now, I don't think they have nodes or anything like that. And we almost the entire autorouter is like capacity node based, our version. Where did you ask originally? It's supposed to sync all comments. Is my X integration not working? All right, get adjacent same layer unprocessed nodes. I feel like I've said this like a million times. We should do a supercut of the stream every time I say that. YouTube. Oh, YouTube comments should show up. Interesting. Also, welcome Snarky Plus. By the way, we're the biggest sponsors of free routing, or at least we were. Since I've had to go down the route of building an autorouter, I tried to get free routing to work a lot for a TS circuit. Yeah, and like the simple truth of the matter is it's very difficult to get enough sponsorship to justify the maintainers like doing a ton of work on it. Do you know of a good co-working spot now that Solaris is dead? I do not, although a couple people have referred me to a couple places. I'll have to see what people referred me to, but yeah, no, I basically work from home now, so in San Francisco. Steve Ruse said was a ridiculous thing to do, but I do it. All right. Each node is going to track its neighbors now. It's quite an expensive calculation, though. Maybe the problem is I was relying on AI too much to write the KD tree or the spatial tree. I feel like I could write a really fast one. I don't know why it's so slow. Should I just write one? Because I think I need it for this thing I want to do, even with these adjacency, even with adjacency tracking, you still have to do an initial adjacency analysis, which makes me think it's going to be really slow. Let's try writing our own capacity node tree.ts. Did you say you intend to publish at some point? Yeah, it's technically it's already out there, but we're going to do a paper and whatnot. So, but yeah, if you use tscircuit.com, the autorouter, kind of an old version at this point, I need to update it, but we already use this autorouter. So we're like always testing this and making sure it works, but we think it's pretty friggin' good, suffice to say. I think it's pretty good. Yeah. But yeah, MIT license, so very unique because most autorouters are not MIT licensed. In fact, we may be the only one. Literally, if somebody knows of another one, tell me. Yeah, most of them are GPL or proprietary. They also mostly are not good. All right. Capacity node tree. Yeah, we'll take a list of nodes. You know, I just realized I kind of reverted some work I wanted to keep over here. Yeah, some of this. Let me get this committed so that I don't accidentally revert it again. But we're just going to do this like slightly smarter to avoid less stupid memory accesses. Yeah, like that. Cursor knows what up. It can see my history, so it knows exactly what I did before. Cursor is the real undo. All right, let's add this guy. slight improvement to node initialization. Do we have intellectual property right IP rights of this autorouter? What? Very cool. Most suck, and the ones that don't are sitting in a pricey EDA tool. Yeah, agree. Yeah, we want to have autorouting.com where you can. We already own autorouting.com. So we want to have it so that you can come here and just upload a file, and it'll auto route for you. Yeah, guys, I don't usually work on non-open source stuff. If you see something on stream and it's not MIT licensed, do whatever the hell you want, open source, I don't know. It's usually the case. The only time is authentication APIs or anything I'm required to sign an NDA for. I will not show on stream. Or actually, authentication APIs I will show on stream, but I won't. I won't make open source because I don't want to tempt people. There's actually a lot of truth to out of sight, out of mind. And people see me streaming. This happens almost every time I work on back end for a long time. Some asshole will come into the stream and start like doing some equivalent of DDoSing. So anyway, this is why we can't have nice things. But for front end, who cares? Because you can only DDoS yourself. Right. All right. Let's see if we can write this guy. So I think what I want to do is I don't even know why we need a tree. Maybe I shouldn't even call it a tree, but we really can just subdivide. Can't we just subdivide? I think we can just kind of subdivide into buckets, and then yeah, I think we can just, you know what I mean? Like buckets. I'm gonna write the most like smooth brain implementation of this, but it will be fast as hell. Security through obscurity is surprisingly effective. Yeah, I mean, just like it's like there's a difference between like security through obscurity and then like just like standing out there, completely naked, which is what it is if you're like live streaming. Like, this is my sensitive API. This is how I do billing, Yes, buckets. And then we'll have this be a center coordinate. So yeah, number. That's such a stupid suggestion. Dash? Oh, you mean like the negative number symbol? What a stupid AI suggestion. I never like look at like stuff people do and think stupid. I usually think lazy. But with AI, I think stupid. You know what I mean? It's the only thing I want to. Buckets. Whoosh. Yeah, so basically we're just going to make a bunch of buckets. The buckets can be based on the bounds, so we'll need to compute the bounds. Whoops. What is all this shit? I don't even know what I'm doing. I can just compute this like with a loop. Yeah. All right, so yeah, we can just have like number of buckets, or maybe we could do cell size. Let's do cell size. I like it when things are bound in reality. So this will be in millimeters. Everything is in millimeters. So you can say cell size is like, probably a good one is like 2 millimeters. It's basically all you need. And then we just say for each node, yeah, we're just going to find out what buckets it's in. A node can really be a member of multiple buckets. So top left, or maybe say min x, node min x. All right, that's nonsense. Yeah, one thing I think people do when they're doing algorithms to like really stab themselves is like they like create all these proportional units. Like just try to keep things in like millimeters or whatever your definite unit is, and then we can make this a function like to get the bucket key. So we'll say get bucket key x number, y number. Yeah, basically like that. Sevi, I am currently making my side project. Tell me if it is a good idea or not. It is an AI terminal, not so Aider, but an AI terminal. I'm going to give you some classic startup advice, which is talk about the problem before you talk about the solution. So I'll why don't you reframe, and then maybe I'll know what the fuck you're talking about. Oh man, it is fun, just talking to random people, right? Like, I don't know. Pokes your brain in fun ways. All right. Argument a string is not blah, blah, blah. It's complaining about, it's complaining it's a string, which is dumb because it's not a string. I might be able to do this. Yeah, there we go. I will show you a preview when it's ready. You know what? You're right. Go off, build it for a couple months, and then show me a person who has no idea what it is. And, just bet it all. Bet it all on the vision. I'm with you. All right, so we're basically adding nodes to buckets. You got a lot of buckets. Hopefully this doesn't take forever to compute. But now whenever we want to know, like, get the nodes, near something, we just ask for the bucket. So let's say get nodes in area. We have to dedupe, so that's pretty annoying. Also, X and Y is a really confusing thing to use. So like putting center before it or whatever, because a lot of people use top left. All right, get nodes in area. We'll say already added nodes. Yeah, like that. Just kind of try to make this more efficient. It's really good suggestions on this implementation from Cursor. Basic stuff. It just it's pretty good at it. Wait, get bucket key. I wrote this function. I didn't even use it. Get bucket key. Yeah, this is gonna return a center. I can't call it a bucket because it's floored, so it's not really a center coordinate. So we'll say bucket coordinate. You drink soft drink early in the morning. I think it affects the health. It's coffee. It's cold brew coffee. It's coffee. It's not a soft drink. It's not carbonated. I'm the king of health. You come in here. You come in here. All right. And then we return the nodes. You know what? Does anybody know if this is a VS Code feature? I would love to know what started this line in like gray text. Does anybody know if that's a thing? Like if I knew for every ending bracket what started it. Like, because this is the class, this is the function, but I can't fucking see it. Like I guess I can look up and see it actually. Now that you mention it. It's kind of like there. But not when like the thing is small, you know? Like it's kind of hard in this case. Does anybody know if that's a thing? Bracket pair colors. I mean, wait, render line endings? No, that's not it. Happy endings. No. Preview the opening. Oh, bracket peak. I was like, this idea is so good. There's no way I even came up with it. You know what I mean? Rainbow brackets. What is this even doing? Oh, you have to. Oh my gosh, you got to be kidding me. For this one, you have to hover? Dude, do it without the hovering. Do inline. Oh my gosh, you're so close. Oh, wait, inline. Oh, no way. Dude. Hell yeah, man. Hell fucking yeah. I don't think it's working. I'm going to reload. It's going to be hover by default, probably. What's this thing called? Bracket, It's called bracket something. All right, this is not working at all. Bracket, what's it called? Bracket peak. Do I have to like, I don't know. There was another I used, I forgot its name. Thank you, imposter. Very helpful. I'm just kidding. Look, that was a little bit of a roast, you know. I'm over here doing the thing, roasting a bit. Inline. Yeah, how do I show inline? What's this thing called? Bracket buddy? That should just be built in. I'm going to use this for like 5 seconds and be like, oh, I'm so annoyed. Always preview always. Oh, preview. Wait, preview curly braces. Yeah. Preview location editor top inline. Okay. On select and hover. I don't know. Oh, hell yeah. You have to go over it. Wait, what the fuck? It only works there? Wait, what is that? $47. Well, it's great. It's not even line. First of all, it's. Oh wait, no, it is line 47. But why isn't it showing it? Oh, because it's an empty. It's like an empty line. It needs to like give a better preview. Dude, there's no way they took this to like 30% and didn't do the last. CSS only. It's implemented completely in CSS. Oh, come on, man. Did they really not take this like preview always show bracket if opening it? Oh, come on, dude. It's just like a regex. Are you kidding me? Wow. Let's go to the repo. Because that's like standard JavaScript formatting. I feel like maybe I'm using it wrong. It feels crazy to me that this doesn't work. VS Code just does it? No, it doesn't. What are you talking about, snark? What are you talking about? All right, whatever. I'm going to keep it on for now. You don't do handmade breakfasts. I mean, I don't know. I eat nuts for breakfast, nuts and broccoli. Fresh salad and fruits every day. What is this? Health seminar? What? What are you talking about? All right, get nodes in area. This looks like pretty good. So I think we implemented it. And if this is faster than AI, then I'm smarter than AI. It's a big deal. It's funny how being smarter than AI was like in 2022 or 2021 was like a given. They were like, yeah, you are. If you made it out of elementary school, you're smarter than AI. And now it's like, no, you're not. It's a complete flip. Like, you don't know, you know, because knowledge is like what people see as being smart in humans. Oh, damn, this is a long stream, boys and girls. And everybody else. Yeah, let's try this again. We'll use our new data structure. This definitely feels like Saturday programming. Not amped. Just stumbling through it. So we need to create a tree. It's not really a tree. A tree is just a really good word, though. You know what I mean? It's short. And, you know, people can think it's a tree. It's not going to hurt them. If it's fast, who cares? Okay. We actually want this to be like twice as big. Ooh, a pasteboard PNG. That looks safe to click on stream. Oh, what'd I do? There we go. Nodes in area. Okay, so we're gonna do for const node, say unprocessed node of nodes in area. And then we'll do that thing we did last time where we add this condition to the end here. What was the condition? It's like you have to be in the current batch. So yeah, there we go. If not. Yeah, there we go. All right. This isn't like the final plan. This is still a very temporary plan because we're going to go through, we're going to store all the adjacent nodes eventually. But we should see, I think we should see a performance increase from this. And it'll also validate that our implementation is kind of working. All right, solve completely. Let's see how long it takes. Time to solve 0 seconds. Those don't look merged though, so I think something is terribly, terribly wrong. 0 seconds though, you know, not bad. If that's what you're talking about, VS Code just does that. All right, I'll click on your link. Yeah, dude, it's at the top though. It's at the top. I want it inline. I want it inline. I have an idea. I should make a Sevi AI who just makes electronics like a simulator. That's a good idea. The PNG is safe. It shows you where to look in VS Code. Thank you. Too little, too late, because I already clicked on it by the time I read that. But what are 3 things you expect to see on a portfolio coding site? That's a great question. And I like how you've given it this kind of clickbaity container for the question. Like, what are the top 3 things? Look, if you're doing a coding website, this is like my preamble to the article. If you're doing a coding website, there are 3 things you gotta show. Wait, no, start with the problem. The job market is competitive right now. I don't know. You know, I really just look at people's GitHub contributions and nothing else matters. It's like the first thing I look at. I stopped caring about other things. I used to measure for many other things, but for now, I just mostly care about GitHub. People are like, oh, no, that doesn't capture great people, blah, blah, blah. I'm like, yeah, but it does capture some people. I don't need to have the perfect interview, you know? So I'm building that too. Everywhere asks for a website. I'm trying to get my wall of green. It's more like the quality of the contributions too. But wall of green is a good start. But you know, I do look at people's specific contributions. I'm like, oh, did they contribute to a project that has more than one person? And was that project like intellectually interesting? You know, it's not like if you do a commit every day to your portfolio site, I'm not gonna really put a lot of weight on that. But if you I don't know, like if you make any contribution to like a real project, that's a pretty big deal. Even a couple of those sprinkled in, it's pretty good. Am I gonna check out portfolio sites right now? I don't know if I want to check out portfolio sites right now, especially on the, you know, my algorithm is not working, which is very sad, catastrophic even. I'm assuming this is just returning nothing. Get nodes in area, center X. Well, this is kind of, yeah, just make that. I don't know if that's going to change. Actually, yeah, that is going to change things. Okay, cool. Yeah, it was being computed dumb. Fair, you good? You good? All right, fine, I'll look. It was so nice of you to say I was good. Aaron McLean. Ready to optimize your embedded system. Refactor your algorithm design. That's pretty funny. That's pretty funny. Very related. Carleton University. Ottawa. It's good. It's good. Yeah, I think how I look at contributions. Yeah, there's some stuff that might be interesting in here. I don't know. Yeah, nothing really stands out. It means like basically you're at like level 1 of 5, I would say. Like level 1 is like you have something on your GitHub, and most people, I would say like 80% of people don't get past each level. Probably level 1, most people don't get past like 90%. What about me, dude? It's cool that you have a neural network here, though. But you talk about on your personal site doing algorithms. I don't know if you just changed that for me to be for it to be very coincidental, but there's no algorithms. That's pretty cool though. How about me, dude? I don't know, man. Do you have a personal site? I don't know. I don't know if I want to do personal site reviews. Who wants to see that, you know? Who tunes in for Sevi doing another week of personal stream reviews or personal whatever portfolio sites? There's nothing on that portfolio site, by the way. There's no like, you know, there's no stuff. It's still not merging. Something is amiss. Can you check mine as well? Dude, you're not linking to it. How am I supposed to check it if you're not linking to it? I'm not gonna like Google you. I don't really know how this could be messing up, actually. It's kind of interesting. It's pretty simple. Let's try logging it here. Yeah, let's try logging the buckets. Oh, it's a empty map. That's interesting. Let's try logging that. Oh, it's got a lot of entries, so something's up. Ah, it's interesting. Okay. Oh, wait. Why is it doing this? Oh, my gosh. Nodes with area. Ah, man. I let AI autocomplete. I'm going to have a no AI day once a week. I keep hoping, like praying, it's going to be 0, and then I zoom in and it actually is working. Let's check out those buckets again. Still no buckets. What is going on? What in the fork is going on? All right, so we go through each node. Oh, wait a second. Oh, this is junk logic. Dude, AI is just bad burgers, you know? This logic sucks. Oh my gosh. It's crazy. If not bucket, we need to set the bucket. Crazy. Oh my gosh. Shibo, hey, what up? What up, dog? Ansh says, am I in your company, dude? Just read my username, AnshGrover23. Just read my username. You want me to... Dude, look at that performance gain. That looks merged, too. See, guys, I'm better than AI. What did I tell you? The iteration count is really high, though, so something is definitely amiss. So the... Oh, man, I can't remember which one of these is right. On my right-hand side, I have the correct answer, maybe. I think this one's not fully merged because some of these nodes look like they could probably be merged together. So it doesn't look fully merged to me. I've been trialing more engineers, and the bamboozlement of, hey, they're pretty good, to, oh, fuck, they're using AI and they don't know shit is real. Yeah, true that. True that. Yeah. Truer words have never been spoken. Yeah, I think this one is probably the real one because that one looks like it has more opportunities for merging. This one looks fully merged. So yeah, you're supposed to have big blocks, not these kind of like straw thin blocks. These straw thin blocks should be merging together. So I think what's happening is the nodes are changing each time. So, but I think we can retain the optimization and still get this to work. So this algorithm, how it works, this merging algorithm is one node will like suck up, it'll absorb another one and get a little bit bigger. So if we want to, so I think what we have to do is iterate on the adjacency matrix in a performant way. So basically we really only want to do this distance check in the constructor, because after that it's not going to be accurate. As nodes merge, it's not going to be accurate. We could also update the node tree. Just like an interesting idea too. There's a couple options. But yeah, it's really only going to work for like the first iteration. So instead, what I'm going to do... Okay. Just lamenting. I'm still pretty proud that implementation is, you know, it's pretty good. I'm just saying. AI was doing all this tree nonsense because I told it to, and then I was like, let's do a node tree that's not actually a tree, and it worked. I'm just saying, kind of. Let's go to our capacity mesh node, and we're gonna add a new optional property. Call it adjacent. Adjacent node IDs. And then we'll say this dot compute adjacent node IDs. And I want that as a separate function because I want to know how much time it takes. Yeah, hiring is like impossible. So one of the reasons I like just hiring, interviewing people, making sure they know what they're talking about, it takes a long time, and it's really difficult in the age of AI when people can basically like get through interviews pretty easily because it's just like a lot of iterations at duping humans on that. There's a lot of tools for it. So, but at GitHub, where you contribute to like other people's project, it requires so much social proof. I really just want to use that as a mechanism because you only need 2-3 contributions to a major project, and I know you're legit, right? It's like easiest signal in the world. Even if you work for Google or something, that doesn't make you legit. I don't even trust that. But if you have a contribution on a project they recognize, you're good to go. And it's not that hard either. I've done contributions on some projects in my days. It wasn't too hard. I learned a lot too from other people. All right, we're going to compute all the adjacent node IDs, let's say for first batch. Do you trust me? Trust me in what sense? We've come to the conclusion that big tech or Ivy League equals red flag. Truth. Whenever you are free at last, the end of the stream, roast my GitHub profile. All right, I'll look at your GitHub profile, Anj. But only because I hate productivity. So first of all, I definitely don't look at any of this. I mean, unless I literally need your email. It is nice you have your email there. That's probably the only part I like, because if I do want to reach out to somebody, it is nice to have that. But basically everything else I ignore. So, I mean, these are notable, but since I am TS Circuit, and I know them so intimately, it's like, it's not going to mean, I already have, like, let's see if there's anything in here that, like, is really interesting. I mean, PG Strap is pretty interesting. That's still TS Circuit, though. Still TS Circuit. Feature make screen pipe. I saw something there. Make screen pipe work on Hyperland. You open this issue. That's interesting. That's a bad issue, though. If you spent time writing this issue, you could demonstrate that you just, like, know a bunch of stuff. Yeah, nothing. I mean, it's mostly TS Circuit, so, like, it's hard for anything to stick out because it's mostly TS Circuit. And, hey, I like it when people contribute to TS Circuit. And this would be meaningful if I didn't know what all of these things were. But I'm looking for, like for advice, you know. It's all TS Circuit, so it's very good. Yeah, I think it looks good, but like I already know what all that means, and, you know. But yeah, there's nothing in there that sticks out. That says I go into different code bases a lot. Like this note companion, that definitely doesn't stick out. I see that in 99% of people who have any green grass, I'm going to see some note application they've built. Just doesn't mean anything. Plus, you can just clone a template or repo or whatever. It's like, doesn't mean anything. It's better than nothing. But yeah, I would say you're more like a, well, I don't know. I can't rate you because you have too many TS Circuit stuff. So it's like impossible. I'm addicted to TS Circuit. Good. It's basically what I'm selling. TS Circuit is essentially, you know, an addictive development tool. I was going to say more stuff, and then I was like, I don't really want this to be in a transcript somewhere. And then, everybody's getting shadow banned now. Initial reaction, this guy's working on a project but doesn't move around much. Yeah, I think, like, the thing is like, if I didn't know what those were, it would be more interesting because I would be, like, scanning for interesting, like, frameworks or something like that. So I think it's just, like, it'd be more interesting if you asked another streamer to evaluate it, which is also me, sadly, yeah. Are you merging common geometries on an arbitrary PCB layer over some kind of variable density grid? We could look at the whole algorithm real quick. By the way, this is viewable online. It's like a URL. If you search TS circuit, you'll be able to find it. So if we animate it, so we're capacity node based, and then each stage routes or tries to. I mean, this is just the mesh stage, but let's actually stop this. Just go to the end. So first we construct capacity nodes. Capacity nodes can be on an arbitrary number of layers. Here, this node is on multiple layers, so available Z is 0, 1. It's kind of hard to read. Can't make it bigger. Or don't care to. No. It's an algorithm stream. I'm gonna do a long video on this at some point. But basically, we use, we construct capacity nodes, and then we like the merging is kind of like irrelevant. Strawing, that's this phase. These are all just optimizations / like, what do you call it? I don't know. Like, I don't know what to call it. It's like makes it faster. It makes it work a little better. Yeah, I don't know what to call stages that do both. Then we construct a graph, which is how each node goes to each other node. And then, so all of that is just putting the problem together. So we put the problem together in a smart way. This is what, when you said like variable density grid, kind of, because in a global routing stage, you don't think, it's called a detailed or a local autorouter when you're or not local, detailed or high density. I call it high density, but that's when you're thinking about where specifically traces will go. This is all high level thinking. So after you have the graph together, I should have animated this one because it's actually interesting to watch animated. By the way, it might be broken because of all the stuff we're doing on merging. To be honest, your question is more than relevant. Yeah. What, my interview questions? Yeah, Ethan knows my interview questions. Or do you mean something else? Yeah, my interviews are pretty fun. I miss giving my interviews, but not that much. All right. Apparently, I totally borked this by doing other stuff, so I can't. Actually, maybe I can. Okay, so this is for a keyboard, but similar thing. Actually, let's just solve it. Or according to that, what are people talking about, man? What are people talking about? So yeah, you get the graph, then you do this thing. I call this capacity planning, but it's basically global routing. So now you're finding paths for each trace through the graph. And this is fairly fast because you're working on, a relatively small graph of nodes. You can see it takes 0 time here. So it's relatively fast, which is pretty unusual for global planning. But we're so smart about the mesh construction that it goes fast. But you can see that these guys are overlapping. So that's a problem for the detailed phase. So then we do this phase called unraveling, which is like the main content of the paper. After that, we do high density routing. And then some things to clean up the paths. And that's how the autorouter works. So it's pretty straightforward to me, but a lot of people, what they do when they're building autorouters is they try to route
a line from the start to the end each time. And then they do rip and replace, which means they're ripping out the routes and each when there's a conflict. So we don't do that. And our high density router is pretty cool too. Let me see if I can show. So we use, there's just it's like a lot of techniques all together, but like this is one of my favorites. This is I call it hyper A star, but it's basically we run A star on sub A star runners that have different hyperparameters. So even at high density stage, we don't use rip and replace. I'm just not. I think rip and replace is annoying. I don't think anybody should use rip and replace. I actually think rip and replace is bad. I think you should use what I'm showing here, hyper A star, which is always going to be faster and more predictable. And then if hyper A star doesn't work, you should use multi-head A star or multi-agent A star, which is slow, but it works. Clever heuristics for A star? I don't think so. I mean, clever, I don't know. There's a bunch of hyperparameters that control. I wish I could animate this slower, but there's a bunch of hyperparameters that control how you there's hyperparameters that tell the Pathfinder to make different decisions, and it changes the cost function so that you get different variants. So what we're seeing, like hyper A star, it's hard to see on stream, but there's 92 variants that are running and competing. That's what this table is down here. So the reason I call it hyper A star is we're running 2 layers of A star, one over different hyperparameter combinations, and then the other is like kind of your regular sequential trace A star solver. But you can see like this one has future connection proximity in via distance. So that's 5. And then there's a penalty factor associated with that. So you can stack different hyperparameter penalties and create a lot of different variants. So this is, I believe this is the fastest way to do high density routing, especially on small cells, because that's like a huge advantage of our algorithm is it works on small cells. And then if none of that works, you have essentially a escape routing problem. So escape routing, or an ordered escape routing problem, which is like an actually NP hard problem. Most auto routing problems, people are like, oh, it's NP hard. It's like, is drawing a line across a screen, like, is connecting 2 points an NP hard problem? It depends. Are you solving a maze, or are you, arguably solving a maze isn't an NP hard problem, but are you solving a maze, or are you just drawing a line from A to B? So most problems, people are using solutions made for NP hard problems, but most of the time the problems are easier than that. Like 99% of the time, the auto-running problem is not NP hard. Otherwise, humans would struggle with it too. Humans aren't magical. They can't just like solve things. So yeah, basically only pull out the NP hard algorithms if you absolutely have to. And right now, we're not really using any algorithms that are super sophisticated. Clever optimization over a family of pathfinders. Yeah, that's a good way to describe it. Yeah, we do that. But that's the high density stage, and I don't even think that's innovative. I don't even think our high density stage is innovative. I think our innovative thing is the stage in the middle called unraveling. I think contributing to one company is hugely better or bad. I mean, people want to see you have experience for multiple companies. Yeah, that's after your Flywire is graphing density magic. Yeah, it's like in between. What I think the thing we do that's, I think, very, very smart and there should be more work on is I might be able to show this, but we like try to reduce the probability at each stage that a node will fail to route. That's like the main function we do essentially. So this stage has this notion of a capacity, which gives you a probability of failure. So it's kind of hard to see, but it says 5 out of 87, 8.75 on screen. So that means 5 traces are going through that, and we believe we have a capacity to fit 8.75. And that's all very flexible. Like you might be exceed capacity, whatever, but it's giving you an approximate sense of probabilities. And another really critical insight for fast autorouters is at first people are like cost functions, A star is about cost functions, blah blah blah. But it sounds obvious to say, but there's 2 competing priorities. One is optimality, which is guided by cost functions, and then the other is search space. You need a really small search space. So the way to build these things the fastest is to run make a lot. Essentially, when we run multiple, when we're doing hyper A star, we're saying we're going to run many opinionated searches, and we'll even let the ones that are kind of simpler run faster and first, but then eventually we're going to run more complex things. So you want to do this where you take the greedy things where you can. If you're wasting time, a lot of people do, any grid-based Pathfinder is wasting time because it's creating a grid that on every problems that don't need it. So you don't want to, you want to be greedy where you can be, and Hyper A Star is just a very, very easy way to do that, because you're saying, hey, I'm evaluating all the runners, right? It's like the same as like, same concept conceptually as like mixture of experts in LLMs. Like I'm going to have many experts and I'm going to decide who to trust. The only thing is with LLMs, I think they many times actually run all the experts. So, you know, with GPUs, the math is all a little different, but yeah, each stage we have a probability of failure of the node. Like right here, this node, we give it a probability of failure of 30%. And then in the next, yeah. And we swap things around to like make it, to reduce the probability of failure. Even though it's like 30%, it's not actually 30%, obviously. It's a fairly easy one to route, but that's cool. Is the capacity estimate deterministic? I've tried to use some GA stuff in the past. Yeah. There's not good stuff out there. Wait, no, you're talking about genetic algorithms. Yeah. Yeah, everything is very deterministic. Everything is very, very deterministic. Like every time I run this, there's no Monte Carlo. We had one part that we didn't know how to do, or I didn't know how to do. And so I wrote a Monte Carlo thing to prove that it conceptually worked. That took like, like a super long time to run, but I proved conceptually it worked. And then I switched it to A star. So everything is deterministic. Yeah, like, so if we zoom in on this, we got like 4 green vias in this kind of central area. By the way, we don't do useless via elimination right now. So you can see there's like this useless via. It's so easy, but I haven't done it yet. I tried to implement it yesterday and I spent like 2 hours on it. Seems like such a simple problem, but I just was losing stuff in the data and I was like, you know what, fuck it. This is so easy. I'll just do it later. Like focus on more interesting things. But anyway, so there was that grouping of 4 green vias. We should be able to find that again if we run again. It should be completely deterministic. Yeah, there it is. So it's completely deterministic. But yeah, yeah. There's a lot of vias right now too. And that has to do with the probability minimization. It will create useless vias because it's always seeking to minimize probability. It might not seem here like this is minimizing probabilities in any way. Like it kind of makes it harder to go this way. But in relation to what else is in this box, some probability minimization thought that was appropriate. It sometimes is very difficult to reason about because of the discrete blocks that it's operating within. So, but it generally it's pretty good. And most of the time when I look at areas, I go, that would be easy. It would be easy to manually edit them. Like, they're not complicated. They add a lot of space, unlike some other autorouters that make it high density. And we do simplify. Like, when we simplify, it does get a little bit harder to route through things. Like, this is kind of relative to before our simplification phase. That's like, it's kind of shitty both ways, actually. Anyway, it was a rant. So currently I need to contribute to various projects. Okay, I am going Sevi. Bye. See you, Ansh. Yeah, I don't know if you need to, TS Circuit is great. But yeah, I mean, building expertise definitely means looking at other people's code and combining ideas. Yeah, no problem. It's all practice because, like I said, I'm gonna do a long video at some point when it's released. We need KiCad support. We really want it to work with KiCad. What do you use, Snarky? Are you like everyone else in the universe using KiCad? There's some Altium buffs out there. Was this built for a research paper? No. It was built because I need it. Because TS Circuit, which is like the main company backing everything, I got funded to do TS Circuit. So I work on it nonstop every day. Quite a lot, I'll add. My grass is very green from TS Circuit work. but it's totally reliant on autorouters. I think that the routing stage needs to be eliminated because it's really just not. I know people are very sensitive about this, but I really don't feel like humans should be spending time routing. Yeah, I'm building it because I need it. Which also means, like, I really don't care about a lot of constraints. Like, people like we have some hyperparameters that are optimized for 0.6 millimeter vias, which is sort of like an industry standard, pretty good size. But I don't care about adjusting that arbitrary thing right now because I'm trying to route boards. And if you have custom board requirements, like, I'll definitely build it, but I'm not gonna do it for the sake of the company. You would have to pay us or something if you wanted. I mean, you can use other via sizes. It's just like, like, I'm not focused on support. People do insane things. They do like micro vias and stuff like that, 0.2 millimeter, and all of those are going to optimize slightly differently, right? Like, we were talking about node capacities. You do have to tune the node capacity calculation to the trace widths, the via size, stuff like that. You can have it as a parameter of the auto router, but like, it's not my focus. The technique will work for anything. Used to use Eagle. Eagle's dead. She used TS Circuit if you get into it again. I'm just kidding. Use what you feel happy with, and hopefully that's TS Circuit. But I mean, TS Circuit is such an open platform. Like, people will probably build. I think if somebody was going to build a web-based EDA tool, TS Circuit would be a really logical choice for the backing platform, because we just built so much. We'd save you at least a year of time. Yeah, Eagle is Eagle is a little painful. KiCad is really great now. Still has many problems, that I think it's very hard for them to solve with such an old code base. But yeah, one of the projects I kind of want to do is build these MCP layers. MCP, yeah, Model Context Protocol. People have been building it to let people like edit Blender in AI, and I was like, man, that'd be pretty cool to do for KiCad. I don't know if I'll be. I was thinking about doing it, but I don't want to like buy too much into the KiCad ecosystem. I want to be compatible, but I don't want to necessarily buy into it. I had a cool workflow with Eagle and SketchUp for board renderings. Poor man's Altium. Yeah. I think KiCad does pretty good board renderings now too. I think you can export to Blender. Yeah, our board renderings do not look as good as KiCad's right now. They have like ray tracing and crap like that, or at least you can export to do that. We sort of have export support. I don't remember what state it's in, if it can capture all the types of models. All right. After that detour, let's see if we can compute adjacent nodes for first batch. Yeah, let's pass in the area or the nodes. Save myself. Now I'm coding like an optimizer. Like I'm like, maybe I shouldn't call that map again. When I first write these, I don't give a shit. I don't give a shit about optimizations at all. I just want it to be like understandable, because the chance of getting the algorithm right is so hard. You know, like you can see it in the repository structure. If you look at some of these, there will literally be 7 variants, because I'm like, I can't lose my progress on this because this kind of worked, but it didn't quite work. So algorithm development is very... I also thought I wouldn't be streaming today, except yesterday I got very lucky and I found stuff wasn't routing. High density stuff wasn't routing. And I just needed to do a little bit of tweaking for a particular capacity probability. And because of that, I'm not spending all weekend writing new algorithms. So, yeah, we just have to optimize what we have, and we're basically good to go for 90% of boards. Like it's really quite powerful. It's just it is struggling with large boards right now. So we need to route. The board I'm trying to get to route is a 3000 trace board, 3000 wire, maybe 4000. And then that's kind of my benchmark. Once that routes, I'll know, okay, I can use this autorouter for a while. Most boards are, most IoT, like simple IoT boards are under 4000, probably a lot under. So if I can do 4000, I'm pretty good. I'm a bit unclear what the project is for. What, the autorouter? It's for routing circuit boards. Like this is a circuit board, right? This is a circuit board. It's just a different view of a circuit board. Like imagine this is green. Those are all the wires underneath. If you were like X-ray a circuit board. So we're just building the wiring setup for the circuit boards. And it's really slow right now. It's been so long since I actually worked. It's been like an hour in the stream. I've just been chatting and not working on the algorithm. But basically, we're going to do we're trying to speed up a phase called node merging. Oh, jeez. Yeah, there we go. So to do that, we're going to find the adjacent, get same layer adjacent nodes, store the adjacent node IDs, and that's it. So because this happens in the constructor where you're really not supposed to do processing, that is probably going to take a while to execute. You're fucking welcome, sir. What, did you give me the optimization? What are you talking about? Oh, you were fucking welcome, sir. Oh, you mean like Red Team Lead? I have no idea. EDF, EDIF. What is EDIF? EDIF. Electronic Design Interchange Format. Does anybody use this? Oh, this is like S expression shit. Oh, wow. I should know about this. Look at that. 1990, 1986. Okay, I think I know why I might not know about it. 1996. Yeah. I don't know. Maybe I'll look at this and try to make a JSON version. It's got to be It's got to be like web compatible for me, but we convert. We have a format called CircuitJSON, circuitjson.com. QGIS, which was map data. Yeah, it's very old. Glad to be of assistance bringing hard-won productivity. I didn't get that optimization today. I got it yesterday. I don't think you were involved, Ethan. I mean, I could be wrong. Maybe you called me up and said something and there was some butterfly effect. Speaking of productivity, mine is dying just chatting, so I'm a piece. See ya. Thanks for stopping in. Yeah, I can't believe I've streamed this long. There's a lot of good chatters today. There's people honestly, I would have stopped streaming except people were interested in autorouters, and I love to talk about autorouters. So I probably have written a parser for EDIF and just didn't know it because I've parsed, it feels like every single S expression under the sun at this point and tried to convert it to circuit JSON or TS circuit or something like that. But I'll definitely have to take a look at that later. Okay, compute adjacent node IDs for first batch. Okay, so we got the adjacent nodes. Oh, we have a little bit of a Let's do this manually. I think I know what I want to do here. So it routes signals from the PC to a physical board to execute real-world actions. I mean, a circuit board, you like plug it in with USB. Like everything around you has a circuit board, right? Your keyboard is a good example. So you plug it in with USB. What are you plugging into? You're plugging into a printed circuit board. Like you're plugging into this. This is again, this is like an X-ray view, but you're plugging into this. One of these ports is put onto this. This is what the port that you plug into is soldered to or glued to. So you plug into this, and then this connects all your keys together on your keyboard and stuff like that. So somebody's got to route those wires, right? Like all these little red and blue pieces of copper, essentially. Humans do that. Humans drag and drop those wires together. So what I'm doing is making it so that humans don't have to do that. And a couple people have tried to do this, but as discussed in chat, they mostly are not great. So okay, so we're basically just rewriting this computation here. Yup. It keeps reversing things, which is crazy to me. Like you should not be I'm pretty sure it reversed a condition. Yeah, that's crazy that AI is reversing that. It's like, it doesn't look quite right in your reference implementation below. Thank you, sir. What's cooler is we might be the best. We might be the best people at doing this, or I hope we are. But I honestly so there's a big project called free routing, and we've sponsored them, but they're a little bit slow. They don't run on web. Given a small enough category, we're definitely the best. But my goal is to kind of match free routing. Although free routing will always be better at certain things. They have dedicated, well, not always, but they'll be better for a while at many things. Like they have a fan out solver, which is kind of what I talked about with the ordered escape routing. It's a very NP hard problem. So they're going to have a lot of stuff that's really, really awesome. Power to them. But hopefully we gradually get there, because I think our technique is quite unique. I did several projects with free routing, use that instead of the Eagle autorouter. The Eagle autorouter is something I have basically never looked at, so I'm curious. But I've seen so many autorouters that just I can tell in 10 seconds how they work, and I'm like, that's not really going to get you there, you know. And at first I wanted it to be so another goal of this project is if we get really good and really fast, we're going to create a massive data set, 1 million auto-routed boards that we generate with TS circuit. And then we're going to train a diffusion model or a conventional GPU model to solve for boards using our autorouter as the base data set. And I'm positive it'll work. You just need enough data. And that'll be really cool. That'll be super cool because that'll give really, really predictable auto routing times. It'll probably be faster than almost any approach eventually because you're essentially memorizing common configurations. So I'm pretty excited about that. But that's going to be a little while before we get there. Not too long, but a little while. Okay, so now we're getting all the adjacent node IDs to the root node. So that's good. Yeah, and we still need this. There's a good chance this doesn't work. I was watching a video about pathfinding AI, or specifically how map programs learn to find the shortest path by considering an oval search pattern instead of a circle. Yeah, there's actually I think I know what you're talking about. Yeah, that's funny. Yeah, there's an algorithm. I'm forgetting the name. There's a lot of interesting algorithms. Was it like a Monte Carlo-esque algorithm, like it had a random component? There's some really interesting algorithms that currently are sort of like locked in to stochastic methods, which is kind of unfortunate. Nobody has, I'm deep enough in the stream where I can say this, but this is my first time streaming in a while. I wrote like part 10. I don't know if that title came through, but I wrote part 10 on the stream, which I think is really funny. I've never done an auto routing. Maybe I've done like some streams where I touched an auto router, but this is number 1. I just figured like part 10, it's kind of like, part 1, who knows what's going to happen, right? I don't want to sign up for a mystery. Part 10, like you're like, yeah. Kind of like, probably they're all the same at this point. I'm getting a commodity product. Okay, so now whenever a node absorbs another node, it needs to add the adjacent nodes of that other guy. So basically, instead of tracing all routes from the start until you find the shortest route, you search in an oval drawn between the start and the destination. You know what this reminds me of? I wrote a post about a type of auto router I was experimenting with that I actually think will work, but it doesn't use ovals. I bet ovals have a bunch of optimizations, but it uses recursive path substitution, and you can route a ton of stuff like this. Yeah, and there's a lot of very, very cool properties of this type of auto router. Or this type of pathfinder. So yeah, blog.autorouting.com if you're interested in that. I thought to myself, he's been cruising on this for a while. Well, I have been working on auto routers for like 9 months, but I haven't streamed about it because, and I talked about this at the beginning of the stream, auto routers aren't very fun to watch developed. Like, I didn't have animations until like a month ago that like you could show. So it's like, we're pretty late in the process now. You have to search a third of the routes before finding the shortest one. Oh, that's kind of cool. Like 1/E. That's pretty interesting. I'll have to look that up. I'll look up oval pathfinding. Let me know if there's any search terms, but yeah, I'm always interested in hacks to make things faster. Yeah, pathfinding for AI in games is really important. I took a lot of inspiration from games, actually. Or it's more like what happens a lot when you're building, I think this way when I'm building algorithms, is like you discover something and then you realize it has a name and it's like a formal process. But it gives you a lot of faith in the technique, so now you can pursue it more aggressively. And one of my favorite things I read from game pathfinding papers was this thing. I call it a greedy multiplier. I think it has some different name, but this is probably one of my favorite techniques, mostly from games. By the way, games, much different pathfinding problem because the nav meshes generally in a game are pre-baked, and they'll actually spend like a ton of time baking the nav meshes, like days. It's kind of crazy, but yeah, games, like if you think about why games are so big, a lot of it is baked nav meshes because they want pathfinding to be fast inside the game. It's really crazy. Anyway, I call it the greedy multiplier, but there's a very simple technique on A star. Trying to find a paper here, but I don't know if I'm gonna be able to find it, guys. A star greedy multiplier. It's like the H term times factor. Yeah, weighted A star. Yeah, there you go. But there's actually a paper on game pathfinding algorithms that I found that was really, really useful. I'm a little disappointed, but they didn't call it a greedy multiplier. I thought their name was stupid. I should have kept their name though, because I'd be able to find this paper right now. But anyway, you can make A star more greedy by multiplying by. See, this guy knows what it is. By multiplying the heuristic by some small factor between 1.1 and 1.5. Games aren't changing the maze while solving it. That's right. That's exactly right. Yeah, this guy's calling it weighted A star. Yeah, 1.5 or 2. I would say like 1.1 or something like that. But anyway, this is crazy. So normally in A star, F is equal to G plus H. But if you multiply it by some factor like 1.1 to 1.5, you suddenly get way faster, like a crazy amount faster. So it's pretty cool. And the reason is you're no longer optimal. So A star is actually optimal. It actually solves for optimal. But this multiplier says it's okay if you solve for optimality outside of, like a little bit outside of optimality. Up to up to W times worse than optimality, essentially. Something like that. So it's super cool, but in practice you usually get something like the optimal. You're basically getting the optimal because it's a high range and it usually doesn't pan out that way, but it's so much faster because it allows A star to be much greedier. I wish I had an animation for it because I've used it so many times. Maybe I can pull together an animation for it. All of my A stars have a greedy multiplier now. It's incredible. If you're not using, this is what I'm talking about with people like, oh, you should rewrite it in C. You should, write in some different language or make it parallel or whatever. Actually being smart about your algorithm. And by the way, watching algorithms animated is one of the best ways to see that an algorithm is being stupid, is one of the best things you can do. Okay, I think this is a, that's not right. Yeah, okay, so here is a pathfinder. I think I can demonstrate the greedy multiplier. Here's a pathfinder. It's connecting 3 traces together. So if I animate it, we can see it. We can kind of see what it searched, and we can see it took 200 iterations. Okay. There's a game called Rain World that uses dynamic pathfinding. Yeah, that's going to be tough. But Rain World is also very small, relatively small. It's 2D and whatnot, so it's not like in COD, Call of Duty, some big games. The nav meshes are really extensive. Yeah. And I mean, Rain World, they render the whole time simultaneously, like they render the whole world. So there's definitely something to be said that Rain World has a very complex problem. But using reverse kinematics, well, I don't know about that. Sure. Yeah, I feel like people always want to believe there's something fancier than, it's just like it's A star. Everything is A star all the way down. I'm a big, like, I said this earlier, but A star should be called fundamental algorithm, and people should know how to squeeze every ounce out of it, like by reducing the search space and pulling every lever, because it's so intuitive and natural. Anyway, okay, so this takes 200 iterations. We can see it like kind of flopping around and exploring kind of all over. Watch what happens when I change the greedy multiplier. So I'm going to go over here. I'm going to go to our capacity planning, capacity pathing solver. And then it's like a hyperparameter. So greedy multiplier is 1.1. All right, let's make it 10. Okay. So what we're doing is multiplying the heuristic. We're making it greedier because if you only have the heuristic, you're very greedy. So now if I animate 144, speed up. so you have to tune these because it's also less optimal now. You can see the paths are like different. It doesn't care as much about getting the right distance now. It cares a lot more about kind of like minimizing like just every step getting better, essentially. Very greedy. If I change this to 1, we're going to see it take more iterations. It's going to like flail around a little bit longer. Or the exact same. I guess in this case, like they are coincidentally even. I've never tried this, but you might be able to set it below 1 to try to like... I have no idea what this will do though. Yeah, so it's definitely taking longer now. But that's like, nobody would ever do that. It makes no sense to set the greedy multiplier low. Essentially, that's saying you should overexplore nodes that you know aren't good. So, yeah, that doesn't make a lot of sense. Yeah, what having it lower than 1 would potentially reduce the number of hops as a second order effect. But there's other ways to do that are much faster. Cool. That was fun to talk about. What is I actually trying to do? Yeah, so this is taking forever to load because like that page, it goes to white for a while because we're computing so much in the constructor, which we're not supposed to do. It's bad practice, but I'm going to do it anyway. And so it solves instantly, but I think it didn't merge anything. So yeah, we've got problems. It should have merged something. It's a little sus. It didn't merge anything. Root node dot adjacent node IDs. Adjacent node IDs equals. Maybe let's just log the nodes and make sure that they actually have adjacent. Does your algorithm use recursive weighting? I don't know what I don't know what recursive weighting means, but it's probably recursive least squares. I don't know if that's a thing. Recursive weighting. If you mean least squares, not explicitly. Although we will for if we do have a linear regression. That's very standard. If you mean least squares. It's got adjacent nodes. Oh, interesting. It's reporting itself as an adjacent node. That's not good. If unprocessed node dot capacity mesh node ID is equal to node capacity mesh. Yeah. Okay. So we've got adjacent node IDs. The only thing I can think of. Let's fix the merging logic real quick. So this is when we're absorbing. So we're saying we absorb that node. Yeah, we want to do that. Jason. AI guess is wrong again. We want to add the adjacent node IDs. We're going to say not ID absorbed node IDs. Oh, we have to add this a lot. That's unfortunate. Because if there's a bug. Oh boy. Whoa, what is going on, man? Like if you try 3-4 paths one way and they fail, but a path the other way gets you closer, then explore that direction more next try. I mean, that's essentially A star. You're describing A star. There's also like what you're describing is essentially A star, but there's also oh yeah, no, I mean, yeah, well, okay, so when you have greedy, if you have a purely greedy function, when it's going to stop is when it literally, if it's going down a dark corner, that's kind of close, but never going to get there. It's going to explore literally everything before it switches to the other side. That's why pure greedy isn't so good. Because at some point you have to be like, give up. A star matches human intuition when doing things. So like, you know, we try something for a little bit, then we're like, maybe we should stop trying the same thing. Maybe we should stop like bashing our head into the wall, trying to do that. All right. So we added the absorbed nodes. I feel like that should work. We're gonna instead of running it all the way, I'm gonna just try a single step because we're kind of debugging like it's not working at all right now. So let me see if I can do this. So that is the node that is supposed to merge with stuff. So if I do one step, looks like it's, yeah, it didn't merge with anything, so it's just not working. Sorry for all my dumb questions. No problem, Red Team Lead. And sorry about what comes to you in Rogue One. Everybody, I don't want to spoil Rogue One. Rogue One is my favorite Star Wars. Anybody watching that Mandalorian? Gotta get on that. Everybody's telling me. I also just realized it's noontime. Oh, I don't want to end on a bug, but I do need to eat. Let's see if we can get this working. Then I can eat happy. Yeah, so it's not highlighting any of the adjacent nodes, which to me says very broken. So how does this highlighting work? Adjacent nodes. So for each node we ask, get the adjacent unprocessed nodes. You were the first person to get it. Yeah, I love Rogue One, man. I don't know if Red Team Lead is only in Rogue One. I feel like every Star Wars movie they're gonna have a new red team, orange team, or whatever. Yeah, red teaming is also like a thing in software development, so you know. Let's see, get adjacent, unprocessed nodes. Come on, let me dine happy. I'll try to keep up with your project. Cheers, color me interested. Thanks, man. Yeah. Good to have more people interested. And yes, there will be many more things to happen for this project. With insofar as releases and to what have you publishing. I don't know. I was trying to think of a improv skills, not killing it. There was the old red versus blue. Red versus blue. Was that a Star Wars thing? Red versus blue. Like was the bad guys the red team? Red teaming is like somebody trying to hack you, or you're trying to hack. You know, if you think of like hacking, capture the flags. The website is down. If you remember that, I don't remember that. Too old of a reference. Or I just didn't see it. Both are possible. The internet is a vast void. We're not all exposed to the same media anymore. We're not all turning on our cable television. Why is this not working? What if I got a little aggro and I just said this really quick? So I'm wondering if I This guy should have more adjacent nodes. Center width. These guys should be... It could be my bucket. It could be my bucket algorithm. I think it might be my bucket. I should have written a test. I think it's my bucket. All right, let's stare really hard at it. This is preemptive. This flooring. You don't need to do that. Yeah, you don't need to do that. It's preemptive. The get bucket key will do all the rounding you need. I don't know if that'll fix anything, but it's worth a try. Red vs. Blue was the first. Ah, that's true. Red vs. Blue was huge in Halo. Yeah, they had the whole series. It's fucking hilarious for any tech person. Oh, wait. The website is down. Hold on. This does sound familiar. Wait. Oh, this is old. Oh, I don't know. I don't know if I recognize this. I'll have to watch it later. I know people want to see me experience this on stream, but I'm getting hungry. I just want this algorithm to work. Oh, it's working. I don't know what I did. I removed that math floor. See, now they're purple. I think it's working. Yeah, there we go. Now it's merging. Yeah, it's definitely merging. Go, 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 go. There's some weird merging, though. I haven't really looked at this in too much depth, but that looks weird. That's not right. Oh, that's interesting. I wonder if that's a pre-existing bug in the algorithm. I'm going to have to do some comparisons. You guys all know this. I'm the only one who doesn't know this thing. You guys are making me feel like an old fogey. Dual-sided floor creates a gap. Dual-sided floor creates a gap. Dual-sided floor creates a gap. Do you guys think this actually executed in 0 seconds or if it completely broke? It looks like completely broke. Wasn't it just working like 5 seconds ago? Wait a second. Now it's not highlighting adjacent nodes. I think I've got some dumb thing going on. Hold on. There's something dumb going on. There's like a dumb bug, not a intelligent bug. Yeah, this is setting a node. Okay, it's kind of starting to make sense now why I did this like this. Okay, why this was originally IDs. I did that like tiny refactor thinking I was being very smart. Okay. Yeah, I apparently do like some kind of shallow clone for some reason. I don't know why. I wonder if it even makes sense to do this. I don't know. I did everything wrong here. I don't know why I did all that. That was quite silly. Okay, so to create the capacity node tree, we're going to do node map dot values. And then we'll do array from. Compute adjacent node IDs for first one. All right. Yeah, the nomenclature here is getting quite bad. That's kind of interesting. That was a really dumb bug. That's just been there, kind of fucking this up the whole time. Awesome. So instead of using one grid, they actually use 2 grids laid over each other so they don't draw pixels at a half step so it lines up. Oh, interesting. Gridding in pixel style games. Yeah, I think I've heard of that. Yeah. I think somebody said it. I think I remember reading it was like a lost technique or something. Like people don't do it as much as they used to. I think it's working now. Although this is really bugging me how there's like seemingly overlapping boxes. Like that shouldn't be present in the merging. Some overlapping is expected because these do exist on different layers. Some of them exist on different layers and it's not clearly sort of drawn. But I'm starting to understand why this algorithm is so slow in the pipeline. But there's definitely I think I think that's bad merging. So I think there's a bug. I got to see if this was present before. But yeah, those are on the same layer. They have the same available Z and they're taking up each other's space. If this is absorbed, right? So we skip it there. If this is absorbed, we skip it and it doesn't count as an adjacent node. I don't know. Could be a pre-existing bug. I'll have to do like a micro revert, but I'm pretty happy with this method of finding adjacency. Seems to work pretty well. You can see the purple. Suddenly the visualization after that fix now is like working really well. But you can see it's perfectly calculating adjacency. Oh, that was weird. Wait. Okay, now it's over here. Yeah. This algorithm goes through like multiple. Yeah, so this one I don't get. Okay, so it's doing this one, but is that right? I don't know which one is supposed to be highlighted right now. I don't know why these are being highlighted. So there's some weird stuff going on. So stuff to debug. I'm glad I'm working on this though, because I've always been a little bit suspicious of this phase. Like maybe it's not working completely because I keep seeing like weird overlaps. So I'm glad I get to dig in and we'll also optimize while we do it, which is always a surefire bet. Time to solve is 0.97. So that's a 4x-ish improvement. TBD if the nodes are actually merged correctly. They kind of look extremely janky and not merged correctly. Yeah, those do not look good. Wow. I didn't think this would be so nightmarish. It's a pretty simple algorithm. So like, why is it so nightmarish? And those could have been merged. I feel like this is really simple. When I absorb a node, I add all of the nodes that are adjacent to that node. That should just work. I think I need a simpler, like a smaller little test thing where I can like understand every step. I can't think of why that would be bad. There's like this filter here, so that could be bad in theory, but should be fine. If you're absorbed, you can't be adjacent to something. I don't know. There's probably some weird bug. Let's try it. This has actually worked for me before. You paste the whole thing in a Claude and you ask it to find bugs. Can you find bugs in this implementation? Sometimes nodes, merged nodes end up overlapping or don't completely, I don't know, merge. I have another theory. let's say this, unprocessed adjacent. Let's say, So I have a theory, maybe if I sort them based on size, it'll get consistent, because I think there was like some attention to that in the original algorithm. Is it possible for the pathfinding to get ahead of it, finding the adjacent nodes? Oh, definitely. I only did this. Well, okay, so you always have to do edge. You always have to construct the edges. But this stage can be skipped. But I like this stage because I can do a bunch of optimizations when I reduce the number of nodes. Also, there's this fun thing where if you have a single layer node, this stage only merges single layer nodes. If you have a single layer node, you can't put a via in it. You're not allowed to, because it can't go to another layer. So that means that if two traces are in the same node, that is a major probability of failure. If those traces have to cross, you cannot do it. So I do a bunch of optimizations. That's what... that's why there's this thing, might be able to show it. There's these things called straws. Yeah, like it always looks a little bit jank, but I don't think this one has overlap. So this is a production one. You can see when it does have overlap, it's different available Zs. So it's like, it doesn't actually have overlap. It just looks weird. But anyway, when you have single layer nodes, we like to convert it. I have a stage that converts it into a straw. So a straw is where a trace has to take a straight path through. I call that strawing. Because basically, if you don't do this, traces, like, they cut each other off inside of a single layer section. And so that's why we create straws. And the straws are based on the flow. So you can see the straw direction changes. It's based on optimal flow. In this case... I mean, this is just a hard situation in general, but like these straws kind of lead into each other. They're not going to be able to, there's like one trace that'll be able to use this, but that is literally how it works. Like a trace will cut off every other trace. Yeah, no, they don't run in parallel. They don't run in parallel. Each stage runs completely separate. Yeah. For the most part, when I'm talking about the pipeline, they can't run in parallel. Pipeline stages can run in parallel independently, but the pipeline has to be run in order for the most part. We can run multiple autorouters, so the whole pipeline we run in parallel. And TS Circuit has this thing called subcircuits, and subcircuits will run in parallel. So we do have parallel auto routing as a whole, but it's not like the default thing or whatever. All right, so I'm just kind of theorizing that the size sorting has something to do with this. Although, like, honestly, I need to like actually build a simpler test for this, because I'm kind of like swinging at the fence without. Dude, these when AI suggestions are wrong, it like destroys me. That makes me so mad. Anyway. Okay. A dot width. Yeah. Okay. So A area minus B area. That's how we sort. I'm also suspicious of this. I'm suspicious of this because technically you need to look. Let's just increase it a bit. You'll see the effect. Actually, we won't even see the effect of this. It's just going to make things slower. But I want to look in a really wide area for adjacent nodes, essentially, for that optimization. Because there could be a scenario where the node is really small, but it's adjacent to a big node, and there's some issue there. Unprocessed. Okay, so yeah, unprocessed. Okay. Yeah, that's fine. All right. Okay, so now we're sorting. That should make it more similar to the original, and that sort's not going to cost much. It's so small. A lightweight closed beta project that offers free access to premium models. Is it like Grok, or because people keep telling me Grok is doing some kind of thing? I don't know why that failed to load a second ago. Let's step through it a little bit. Make sure it's executing okay. Yeah, I'm really curious about this edge case. Like, what the hell is going on? What is it adjacent to? That's such a weird case. And then here we have an issue. It doesn't think this node is adjacent. So that's already quite interesting. It's interesting how the left side wasn't picked up. That kind of implies there's something wrong with the math.floor versus math.ceil, because it keeps not picking up this left side, and it should be merging with that left side. It's actually a mistake. That kind of would explain a lot of discrepancy if it's never merging with that left side. It's not Grok. Interesting. I don't really want to spread it around. Send it to me in Discord. The TS Circuit Discord. It sounds like you're peddling something sketchy, but I don't need free models. Like, we're a funded company, so it's not like, you know, it's probably not going to have like the biggest impact on me. There may be somebody who cherishes it more deeply. It also kind of sounds like maybe they are operating off stolen keys. So this took 1.4 seconds, which is cool, but it clearly didn't merge. We also have merge overlap. Did I give this to... Oh, yeah. Key issues identified. Inadequate adjacent node management. Okay. Flawed merging logic. That's probably not it. Incomplete spatial awareness after merging. Yeah, but we don't use the node tree in subsequent operations. I found that usually most of its suggestions are like wrong or don't matter, but then every once in a while it like actually nails the thing that's wrong. Nah, mate, just trying to be helpful. Yeah, I don't know. I'm skeezed out, homie. I'm skeezed out. You skeezed me out. Coming over here selling free stuff. Nothing's free. No free lunches theory. Processing order problems. Growth can make this ordering suboptimal. Well, that's true, but I don't know if it matters. It didn't really... I don't think so. Occasionally smoking hole in Battleship, though. What are you guys talking about? Occasionally smoking hole in Battleship? What are we smoking here, boys? I'm gonna make that just 5 because that's ridiculously big. If we look at how big the biggest node is. Oh shit. Why isn't this working? Come on. Can I not measure? I'm supposed to be able to measure. Come on. Oh my gosh. This thing, the constructor speed. I bet that's an expression. It sounds like an old military expression. Ah, the old smoking hole in the battleship. Yeah, so 5 is pretty big. 5 millimeters is pretty big. It looks like we have some nodes bigger than 5 millimeters. Yeah, so we'll search like an area of like 10 by 10 for adjacent nodes. And then we know we're definitely picking up the nodes. Oh, man, I'm probably going to rewrite all of this later because I'll be like, I cannot deal with the haphazardness. Kids these days. Large obvious problem equals smoking hole in the battleship. Yeah. Oh, I see what the Claude solving. Yeah, it would find a smoking hole. Yeah. Smoking hole sounds like some insane thing. Like, oh man, dude, you've fallen so far. You're smoking hole. All right, we're gonna give this one more go. Give this one more go. What did I even change? Man, this constructor. Oof. Need to wait just for the constructor. It's because that increased search area for adjacent nodes. That makes some sense. Bay Area translation is probably different. Better than... Oh my god. Red team lead. Risque. There goes my E for everyone rating. All right, it's definitely capturing everything adjacent now, which is awesome. It 100%, everything makes sense now. Thing is, that constructor was extremely slow. So, but this might actually work now. Let's see. We'll solve completely. See how much time it takes. Nah, it sucks still. All right, well, I don't know if I got to win this stream. I think we fixed something in some adjacent library. But, you know, sometimes you stream for 4 hours and have, you know, less than you'd like. So, but everybody, thanks for joining. Part 11, we will continue with our auto routing adventures. So stay tuned, and yeah, thanks for joining. This would be a nightmare without a visualization. All right. See everybody.